Oh, good afternoon or evening, I suppose. How's it going, everybody? I had such a long day today that I almost feel like I don't want to hop on. But you know, it is what it is. I promise. And let's see, what are we gonna do today? I want to cover an article. Let me also bring down the volume a bit. I'm gonna bring up an article that I saw recently. It's pretty interesting because it was talking about how the discussion with countable infinities and uncountable infinities and like the history of it. And if we do a bit of that, I probably want to also tackle some like actual problems. Something chill, like some practice graduate level questions. And following that, I think there's some time for some gaming. I think that we can do some fun stuff. I usually play League of Legends, and I'm not sure if that's a game you guys would want to be able to play. Or I'm sorry, that you guys know of. But I suppose League of Legends like hits all the categories, so anybody can be playing it. I think I'd give it a shot. So later today we'll be breaking down some neat stuff. And then another very important thing, I added a new redeem. So if you look in the messages, it should be here. I could have sworn I had it prepared for. So you guys would be able to use a toggle. Maybe I didn't enable it. Hold on. Gaussian, how you doing? I saw you guys were playing Peak a while ago. Did you guys win? How do you win in Peak? What's the condition? You won by having fun. I suppose that's worth it. Yeah, I actually really love those friend slop games. So Peak is one that I really want to try. Lethal Company, I know it's a classic. It's so fun. I used to watch like people replaying like a session or so. It's so good. Let me see. I wonder what the deal is with the... Anyways, let me see if I can toggle the... You like content warning a lot? Surely you did like just fine today. What I did today, let's see, I worked an extra shift because I had to take my day off for Pi Day, for my debut. That person that covered my shift, she had something to do this weekend, and so I had to pay the favor back and make up my money. You know, that's the grind. That's the grind. I guess I can't get it on. Anyways, maybe I can toggle it, and I'm gonna see what's happening behind the scenes. But basically, you guys would ping one, and thered be me mewing, Aleph mewing. That's the idea. Oh, I gotta figure it out. So, and then I'll be putting more stuff later. I'm gonna get some. So Nep, you probably know this better than me. The Twitch integrated thrower system. So I want to get some throwables, and maybe I can make some for myself that is just funny for it, and that'll be another redeem, amongst others. So slowly starting. I haven't had time to do too much. I took a nap earlier before I got on. I was so tired. Let's see, and I have to drive far. I have to drive like an hour away. Okay, so what I'm gonna do right now, let's cover a few things first. I'm going to talk about the theorem of the day, and I'm going to talk about that, the article, that I was talking about. Publication. So there's some really interesting, there's a quantum magazine So one of the discussions, I'm not sure what the legality is on that, but I think reading things on stream, it's a public website. So surely I can just read it out loud and things are fine with that, right? Let me see. I believe it's this one. Okay, so let us go over and I'm gonna show you guys the theorem of the day. Okay, let's move over real quick. So today's theorem, it's this one's pretty chill. So if you guys have done any bit of calculus, which everybody should have, totally experts in, right? Today's theorem talks about, I know, the change of variables theorem. So if you've done anything with, let's say, polar coordinates or more of the harder stuff, maybe Gaussian, you know these then. That taught me calc. This one's pretty chill. This one's a very important one because of physics and the phenomena of using polar coordinates versus Cartesian coordinates. So you can change the variables, right? I remember doing some stuff with Jacobians, but let's see. Some of the hardest work that I had to do was in my math methods classes. That was pretty rough because of the crunch of math that you had to learn. You know, did you cover like Fourier analysis, Fourier series, or anything regarding like breaking down a wave of that regard, something like that? Yeah, right. So these were one of the many things that you had to learn. So change of variables there. Let me go ahead and read it. Let A be a region in R squared expressed in coordinates x and y. Suppose that a region B in R2 is expressed in coordinates u and v. May be mapped onto A via a one-to-one transformation T specified by continuously differentiable function x equals p of u at v and y of q of uv. Then for a continuous function of A, you do that double integral where the Jacobian is the determinant of your partial derivatives. So in other words, you can change your variables. So instead of talking about x and y like on lines, you can talk about r and theta for spherical coordinates or circular radial coordinates. FFTs, you do use a lot of FFTs in your research. Yeah, because you're doing like I wouldn't say nanoparticle physics. It's let me get this right. It was laboratory. It was tiny things. So you're testing material science. It's a material science thing, right? It was something material science and with the tiny things. So you're blasting little particles with large amounts of radiation. You're doing spectroscopy on it. That's pretty cool. So, but wait, I suppose you wouldn't have to do Jacobians, right? You wouldn't have to do anything with change of variables, do you? So where'd my music go? I could be a little quiet like that. Spectroscopy. Only in classes. That's fair. Let's see. So this one is a pretty standard one. Today's theorem was pretty. Everybody uses it. Yeah, if you have packages for Python, you can just let it do the stuff for you. I was a baller and I wanted to grind them all out myself, including coding some of these functions by myself, but I realized some of it's a little too hard, so but pride is what teaches you the hard stuff, right? So this one, yeah, so that theorem is pretty all right. People use it, but let me go ahead and take a look at tomorrow's, and then I'll get into our article. So because I'm not gonna be streaming tomorrow. I will be. Oh, that's what I could do today. I can make the rest of my schedule, and I can show you the process on how I made my schedule. I made that graphic in Blender, of course, because that's the only thing that I know how to do. So let's read this one. This one's tomorrow's, and this looks like a lot of junk. Oh no. So the Gerard Newton identities. Oh man, me too. This is too much. The Gerard Newton identities. For a fixed set S of variables denoted by EK, where K can be between 0 and the size of the number of things. So let's say if I had 5 things, all it's saying is that EK can be from 0, 1, 2, 3, 4, 5. That's it. So the kth elementary symmetric polynomial in the variables of S, so that EK is the sum of all elements in S up to the number of things in S times the product. It's a sums and products question. Okay. With E not is equal to 1. Terry, how you doing? Is that you? Is that really you? Tender, excuse me. Tender VT, hi, how you doing? I'm doing some math. Or breaking down some math. I don't get to break dance. Well, one day I will do it. Hello, Tendy. You had a name of another guy that I knew of. So, welcome to the set. I just realized too that my stream elements is not working properly. So, if you notice my little things on the side, so I have that payoff, the cardinality, and distinct subsets. So that's supposed to be a cheeky thing. So cardinality is a fancy word for how big is your set. So all odd numbers up to 10, right? So 1, 3, 5, 7, and 9. That would be 5 things, right? So as we get followers, I'm calling you guys the set because I'm from Fractal. Get it? It's supposed to be smart. And then distinct subsets is supposed to be the subscribers. So that's also pretty fun. So distinct subsets would be pretty cool. Hi Pen, how you doing? You playing more octopus game? I'm breaking down some theorems right now. TLDR, you don't have to quite get it, and then the last bit, you know, I don't really expect any money out of this, but payoff is the game theory term for what you get when what's your win condition, right? Octopus Tuesday, I think. Okay. And you're doing Mario, the random Marios. How is it tied to Pen in the chat, he was been playing like this one Mario randomizer, and it was tied with another friend's stream of Link to the Past. So it was stuff that in Mario ties to the Zelda game, and then stuff in the Zelda game ties into Mario. Wait, but what does Mario need exactly? What are things that you would end up getting? Multi-word rando on Sundays. Oh, okay. I'll definitely try to check that out. I'm probably not going to stream on Sunday next week because this is like, it's my actual only day off because I work every day. So I do want to enjoy some time off. So anyways, maybe you tell me if you know this theorem, the Gerard Newton identity. So like I just broke it down. You have a fixed set of variables and it's denoted by EK. So with the subscript up to numbers of things in your set, right? So you have 5 things in your set, then 0 to 5. Then the kth elementary symmetric polynomial in the variables of S, such that, you know, the sum of all these guys times itself with E0 equaling 1, denote the kth. Wait, you denote pk, the kth power sum over S. That is it's raised to the power. That's it. That's the sum of all of them to its polynomial. Then for the following recurrences hold. K is equal to a sum with alternating signs times the power and the sign. PK stands for Plant Kingdom. That's what it should stand for. You know what? There's a reason why these things are so dense, because not everybody knows. This looks like it's a number theory thing. So not everybody necessarily studies number theory. I'm not the best at number theory either. But this seems to be like everybody ideally should understand if I break it down. So I guess I could probably show a few terms for this, but how is it a theorem? It's an identity, right? For a fixed set S of variables denoted by that is, each of these guys is the product of its number, with E0 equaling 1. Denote the pkth by the kth power of power sum over S. So yeah, so you would have x to the 0, x to the 1, x to the 2, 3, 4, 5, like a polynomial. Then the recurrence holds that you have alternating signs up to k. You have your polynomials, and then you have your other script. Sure, I believe you. So I think it looks like this has to do with recurrences. Hold on. Expanding, take it to the example that gives a polynomial whose coefficients are elementary symmetric polynomials. So let's zoom in on this bit. With the set S of variables being the set of roots lambda of the polynomial. These in turn can be written via Girard-Newton identities and back substitution in terms of powers of sums of the roots. Example, the constant term lambda 1, 2, 3, 4, we're not going to get a half-life 3, but sure. So half-life 1, 2, 3, 4 is equal to E4, which is equal to this sum. Hey, this looks familiar. An application. This is a network on the left wishes. Okay, network on the left wishes to discover the number of spanning trees connected, cycle-free, containing all vertices. Example, bold red edges above left. Okay. So, how many number of spanning trees are in the network without revealing to anybody their interest in this information? Okay. Via the max matrix tree theorem, this number is obtained by the matrix M, center top, this one right here, which records the edges between B, C, D, and E, weighed negatively, and their vertex degrees on the diagonal. Okay. So that's that matrix. B, C, D, and E are these relations right here. So we don't have A at all. We have B right here, which is connected to A, D, C, and not E. So B is connected to itself, surely. But wait, why are the other ones still negative? I'm confused on that. It records the edges B, C, and D weighted negatively, and their vertex degrees on the diagonal. Oh, like, how many things is this connected to? 1, 2, 3, 4 things, right? So 4, right? 4, 4, 4. Everything's connected to 4 things because this is a pentagon with everything touching itself. Yeah. Okay. In fact, we can calculate the constant term E4 of the characteristic polynomial CT of the matrix. Of course, A cannot ask for this information. Whoever this A is, you're doing this thing by yourself. You cannot ask for this information. It would give the game away. But with the value pk in this case is precisely the sum of the diagonal elements of m to the k. So this matrix to the kth power, which can be obtained thus. The contribution of, say, B is the number of ways B can make a circular walk of k edges in the version of the network of the on the right. So B, the number of ways B can make a circular walk of k edges. in the version of the network on the right, with an odd number of non-loop negative edges, causing a walk to contribute negatively. Honestly, at this point, I don't even understand what. I was on board with it for a minute, and then now it's lost me. So A collects these innocent seemings, circular walk counts from each vertex, reconstructs the PKs, and presto, counts spanning trees. Sure, bud. So this looks like a number of ways, like a game where you would be counting how they move around. And I'm not sure how the counting method is done. So that's okay. I you know, bit off a bit more than I can chew, so that's okay. But that's a pretty interesting one for now. Hello. Was that you, Ryler? Ryo, how you doing? Thank you for the sub. You don't have to contribute too much to me just yet. I don't have any like rewards for subs yet. So, but at some point I will be doing stuff in the future. I just broke down, and by broke down, I mean I'm even more confused by this theorem. You are now a distinct subset. My little terms I have for the set stuff, I'm calling my cardinals the cardinality of like the follower count, and then distinct subsets than the people who subscribe. I thought that was clever because it's fractals, and fractals mean set points. And okay. So how you doing? I hope you like math. Let's see. So this one's a bit dense. Do you know there's a black line on my screen? Wait a second. What is this from? Oh, I know what it is. I think that was from you doing something. I blame you. Let's see. What is this thing from? Oh, that's from my camera. Oh, shoot. My YouTube. Let me trim that real quick. It's because I did something. There we go. Is it back? Thank you for letting me know. So, yeah. Next thing I'm gonna do, I'm gonna try to do a reading of the article that I thought was pretty interesting. Also, this website, again, it's called Theorem of the Day. It gives you a different theorem to talk about all the time. So tomorrow's happens to be that weird the Girard-Newton identity, but today's happened to have been the change of variables theorem, which you probably remember if you ever changed into spherical coordinates. Or anything with like Jacobians and stuff like that. Sent it to the kernel. Yes, it is gone. I intersected it with the null set. But I should make that a thing too. There's so many fun things I can think of for like rewards and stuff. I thought you guys could probably hear me out on one. I always thought it'd be really funny if we could do like a game where you guys get a list of numbers when you get to collect rare numbers like Pokemon cards. That is like the geekiest math thing that I can think of. But what I can probably do with that is I can do math on your sets. So if everyone in chat for some reason had like the different list of numbers, this would be for like participants, right? I thought it'd be fun if we could do a game where like, let's say it's a punishment game. So if you guys would get extra numbers in your sets and you're trying to get the biggest number of numbers. Does that make sense? And I can do things like I could eliminate your even numbers, or I can get rid of all numbers divisible by 3, or any number that doesn't have an algebraic expression like your fancy irrationals, then they like the transcendentals, excuse me, then they are gone, or something like that. Or you get to use your numbers at me. I think that's like, again, peak math geek. Like, you have to really make something that sounds funny, but like you guys could like collect funny things. Like you collect like the square root of 5, you know, why not? You can collect 5, you can collect 3. Guys, you got any 3s? Who wants to trade me for my 2, you know? It's so dumb. But it's probably gonna be some programming behind the scenes, and I want it to be a little interesting because that'll tie in with some rewards and stuff too. So you can throw a number at me, and then I don't know. Let's say it. If you happen to have that number, then you can use it. But consumable, I'm not sure if that's fair. But throwing numbers would be pretty funny. Anyways, let me go ahead and talk about this next thing. This is from the Quantum magazine. This is a paper about infinities, and hey, look, I make an appearance. My Alephness is there. Yeah, a streamer bot can probably handle that. I don't think it's impossible. It's literally like the code bit of code that makes coding easy, right? So if it's just using the numbers, we don't necessarily need the theory, and it'll work out just fine. So before I get started on this article, I want to ask you guys, since some of you guys are, you know, nerds too. Do you remember this little visual on the left right here? I need a pointer finger or something. This little arrows and stuff. You made a Monty Hall problem. Oh, how would that work? So wait, you'd have like an infinite number of people, and then like someone joins, and you like push them into the last, the first place, and everyone else goes backwards. How does that work? Here's a finger. Let me tell you what a finger is. You don't know. You never experienced brutality like I have. It's the guess the door one. Oh, that's the one. Okay, I thought it was the hotel. The Infinite Hotels one. I forgot what it's called. Yeah, Monty Hall says that if you have 3 doors and you choose one of them and you get revealed the other one, then the probability increases, right? So if you know, if let's say you want like one of these doors has $1 million and one of the doors is revealed to you that does not have the $1 million, should you switch your answer from door A to door B? Because now you know door C is in fact not your answer, and it's, you always have to change your answer. Is that right? I think that one's the case. So, oops. Let's see. Yep, you go from a 33% chance to a 50% chance of winning like that. Yeah, you're meant to switch. It's pretty weird. How does the probability increase? There's so many videos covering it. I think it's pretty alright. But even I'm still quite, like, confused by the probability of it. And it's not necessarily... It's like... It's not statistics either, because thank goodness it's not. But I do think it's pretty... It ties in with, like, combinatorics. It ties in with, like... basic probability stuff. I think that's kind of cool. Let me see. I'm moving some stuff around real quick. Okay. Once you code it, it all comes together. Really? At some point I'm going to do some coding challenges too. I do know that there's Euler project. And that's a really good resource for like forcing yourself to like learn weird things. And actually coding it to make sure that it works. That's really cool. I'll have to ask you about that because that sounds so cool. Now, real quick, let me go ahead and get started on our theorem, or our paper, excuse me. So, this here, this is the diagonalization proof for irrational, or for showing that the fractions are countable, right? So the person that made that was Cantor, right? So that's the dude, I believe, in the... Shoot. Is it the guy on the left or on the right? Was Cantor a nerd? George Cantor, that's his name. And he is, in fact, well, when he was younger, he was the guy on the left, the blue. And the other guy right here, it's actually gonna be, his name is spoken right here. So it is Dedekind. Richard Dedekind is on the right. So this is an article talking about how infinity was stolen. George Cantor proved that there are different sizes of infinity and changed math forever. A trove of newly unearthed letters shows that it was an act of plagiarism. So, infinity, guys, there is an infinity heist. How and in what regard? That is crazy. So, one of the things that was pretty cool, he cut me. Dedekind cut me. I remember Dedekind in like some of the... Dedekind was... Oh, wait, hold on. No, actually, let me... I remember... What did I learn Dedekind from? It was like... Was he cutting stuff? Diagonally, not diagonally. Diagonally. He did number theory stuff, so like... Mainly the major redefinition of irrational numbers in terms of arithmetic terms. He constructs the reals. That's where the cut joke comes from. Dedekind cuts construct the reals. That's right, right? Because that does get covered in this article, and you'll see what it's about. But you're right. Dedekind, he was super into set theory and this kind of math. And reals weren't really taken seriously at the time. This was what, 1874, 1870s. Earlier than that, mathematicians did not take the idea of infinity too seriously because one, it seemed like a fool's errand, right? And there's some concepts of infinity that are like contradictory and don't make sense at all. And two, it was sort of like a religious, not entirely the reason why, but there are some like religious implications of challenging and understanding the idea of infinity, which tied into like the idea that you're, challenging God or something like that, or trying to understand God, control God, because God is the almighty being, and infinity would imply that it is beyond understanding. You get what I'm saying? It was something in that regard that it talks about in this paper. Oh, you have a good one, Pen. Thank you so much for coming by. I appreciate you checking this out real quick. But I'll ask you about that bot stuff in a minute. Don't worry. So let's go ahead and get started with the article. This is by Joseph Howlett. He published this back in February, so this is like one of the newer papers. And hopefully I can read with a decent reading pace. I may not be the best at reading, but I hope you guys will serve, because this is also a pretty long article. So I'll probably skim like the big beats of it and get to what the big reveal is at the end. So let's go ahead and get started. When Demian Goose followed Farron Richter into her office on the March 12th of last year, the first thing that he noticed was a bust. The bust sat on top of a tall pedestal in the corner of the room, depicting a bald, elderly gentleman and a stoic countenance. With a stoic countenance, Goose saw no trace of the anxious, lonely man who had obsessed him for over a year. So this is contextualizing the bust, the headpiece that he would get, it depicting, I believe this is going to be Dedekind. Oh, I'm sorry, or Cantor. Cantor turns bald. So it's probably Cantor. Yeah, it is. Okay, instead, this was George Cantor as history saw it. An intellectual giant, steadfast, strong-willed, determined to bring about a mathematical revolution over the clamorous objections of his peers, right? You have a good one too, Fryo. You have a good night, okay? Okay. So, Cantor, they described him as like kind of antisocial and kind of a loser, which, I mean, in some regard, some of us all are. So I can totally understand why he's coming out and saying like, this is how history saw him, and versus the actual like how he was during the time. So it's pretty interesting that they're setting it up like that. Next, it was here at the University Hall in Germany that Cantor launched his revolution 150 years ago. Here, in 1874, he published one of the most important papers in math's 4,000-year history. Dang, that is a big claim. That paper crystallized a concept that had long been viewed as mathematical malignancy, to be shunned at all costs, infinity. It forced mathematicians to question some of the longest-held assumptions, rocking mathematics to its very foundations. And it gave rise to a new field of study that would eventually bring about a rewriting of the entire subject. So imagine this guy comes out with a paper and it says, hey guys, I got something really cool and it's the newest thing. So the new trend, guys. And your kids are going to love it. So, and it's called infinity. But infinity's been talked about before. It doesn't make sense. Nuh-uh, I made it cool. Guys, try it. That's kind of the idea of how they're representing this. Goose is the researcher, mathematician, 35-year-old mathematician and journalist that had come to Hall, a 5-hour ride from his home in Mainz, to look at some letters from Cantor's estate. He'd seen a scan of one that was pretty sure he knew what the others would say, but he wanted to see them in person. Richter, who, like Cantor, had spent her entire career here, first as a researcher mathematician, and then, after retiring as a lecturer in the history of mathematics, gestured for Goose to sit. So this person, Richter, who, I'll look into her in a bit as well, too, study this and happens to be, like, a Cantor fan. So she was like, all right, sit down, Sonny. She lifted a thin blue binder from the scattered piles of books and papers on her desk. Inside were dozens of plastic sheet protectors, each one containing an old handwritten letter. Goose began flipping through, contemplating the letters with the relish of an archaeologist entering the long-lost tomb. Then he reached a particular page and froze. He struggled to catch his breath. This is dramatic, guys. It wasn't the handwriting. At this point in his research on Cantor, he'd been accustomed to the strange, nearly indecipherable Gothic script known as current schrift. Current schrift, which Germans used around 1900. I'm guessing that's a style, like how a cursive to us looks like gibberish. And our literacy has gone down. I can't read old. I mean, I can, but it's hard, right? Old school cursive, that's the same style they're dealing with. It wasn't his signature. It wasn't the signature. He knew the German mathematician Richard Dedekind had been a key player in Cantor's quest to understand infinity and solidify math foundations, and that the two had exchanged many letters. It was the date, November 30th, 1874. He'd never seen this letter before. No one had. It was believed to be lost, destroyed in the tumult of World War II, or perhaps by Cantor himself. This was a letter that had the power to rewrite Cantor's legacy. The letter that proved once and for all that Cantor's famous 1874 paper, the one that would go on to reshape all of mathematics, had been an act of plagiarism. No. Guys, I'm telling you, mathematicians cheat all the time. Researchers cheat all the time. And clearly this is it. This is one example of that. If the guy that made infinities popular did it, what's stopping me from, like, doing that as well? And you guys, I'm not condoning academic dishonesty, but I'm saying just don't get caught. Okay. So, a meeting of minds. Cantor was born in St. Petersburg, Russia in 1845. When he was 11 years old, his father got sick and the family moved to Germany to escape the dangerous Russian winters. Cantor would live there his entire life and eventually lose any trace of his accent. but he never felt totally comfortable in his adoptive home. As Cantor's father continued to decline, he placed all of his hopes on the eldest of his 6 children. For Cantor's confirmation, his father wrote the 15-year-old boy a letter, warning him that many promising talents are defeated by those who resist their ideas. Let me read that better. For Cantor's confirmation, his father wrote the 15-year-old boy a letter, warning him that many promising talents are defeated by those who resist their ideas. Okay? There is only an unshakable religious conviction. Only an unshakable religious conviction would prevent him from being another so-called ruined genius. So, have balls of steel, really. In order to meet his potential as a shining star on the horizon of science, he would have to persevere in the face of his detractors. Cantor carried his father's letter with him for the rest of his life. He internalized its heroic view and intellectual defiance, and he soon found a place to direct his own talents, mathematics. As he put it, math was the field toward which the unknown secret voice calls him. Okay. I went into it because I failed my music audition, so I went back for reasons. But math is pretty easy, isn't it? For some. Okay. So, at 18, when his father died, he used his inheritance to enroll in the University of Berlin, one of the great capitals of mathematics. There, a conflict was beginning to simmer. Ooh. You see, so starting to bald a bit there. You see that? Baldy. The issue was infinity. Mathematicians had invented the abstraction millennia ago to deal with a problem that, for many at the time, for any number you name, you can always name a bigger one. But infinity came with its own problems. The ancient Greek philosopher Zeno used it to concoct all sorts of paradoxes. When infinity entered the picture, straightforward concepts like size and addition seemed to break down. So Zeno's paradox, if I remember, there is one that talks about a race and how you can never win the race. Because if to get there, you'd have to at least reach halfway. And to get to the next half, you'd have to move half as much. And then you'd have to keep going half again. And then meet half again. And then meet half again. And then meet half again. And keep doing that all the way. But you don't actually reach the end, do you? Right? So that one's the one of them. One of many. But that one's pretty interesting because we understand now that what he's describing is a geometric series. And it in fact does converge. And convergence is an idea that didn't exist for them. But they are contemplating the idea of why would I need to be there if I can't reach it, right? So maybe I can probably even show an example of this. Maybe I'll animate that. That actually sounds like a good idea. So the issue was infinity, right? But infinity came with its own problems. The ancient Greek philosopher, okay, we read that. Infinity also presented a religious challenge. Christian theology decreed that God must be greater than any of his creations, the only true infinity, bigger than any number, right? If everyday mathematicians can control this unquantifiable quantity, it would be an affront to God, and thus the authority of the church. Very interesting. So, you cannot start talking about infinities because God is the ultimate infinity, right? So, they thought, hey, the more you start dabbling in this stuff, you are... What happened to my page? Yeah, I pulled up Blender so I can show it real quick, but I was going to do that. Okay. It would be an affront to God. God is the ultimate infinity, but the new mathematicians would be playing around with infinity, and God is the ultimate infinity. It makes sense. You guys should not play with that. That it could be blasphemy. You know better. So that's why it wasn't dabbled in those times. Not necessarily. For thousands of years, mathematicians evaded these hazards by agreeing that infinity was just a useful trick, not a valid mathematical entity. As the great mathematician Carl Friedrich Gauss put it in a letter in 1831, infinity was nothing more than façon de parler. I don't know how that says. A figure of speech. So infinity is not real, guys. It's all a scam. Or so we thought. But within a few decades, infinity became harder to ignore. The elephant in the room. Address me. Address me. Mathematicians were starting to revisit their most fundamental concepts, hoping to make them more precise. Even their understanding of what numbers were, they began to realize, lay on shaky foundations. Until then, they had only thought about numbers as the answers they got when they solved equations in algebra, whole numbers, fractions, square roots. Go away. Whole numbers, fractions, square roots. Now, some of them wanted to explore how these different species all related to one another, and whether there are other species out there to discover. Among these explorers was a quiet German mathematician named Richard Dedekind. In 1858, he found a way to rigorously define all the real numbers. This is that Dedekind cut joke that Penn had made earlier. So, reals now are on the table, okay? Beforehand, mathematicians were dealing with numbers like, numbers that could terminate, or the idea of an irrational number, like significant ones like square root of 2, pi, e. But what about the other ones that don't get a special name? There's got to be infinitely more of them, more real numbers than like whole numbers, right? That's the idea, and he made defined it properly. He said there has to be more real numbers than there are countable numbers, and we will talk about the infinities that it scales with that. There's a power scaling to infinities with this, and he power scaled all of the normal math numbers, if that makes sense. So he was the first, like, he's the villain that mathematicians would have to beat before he becomes a playable character. Yeah, does that make sense? Yeah, sure. Awesome, enjoying a little beverage on the side. So, it's a night, it's the weekend. Let me enjoy myself. So, he says here that any number, he found a way to rigorously define a real number, any number that appears on the number line, but he didn't share his finding. A slow and methodical thinker, he preferred to discuss his results with others until he was sure he was right. In 1870, meanwhile, Cantor, unaware of Dedekind's work, had finished his graduate studies and was starting to examine practical questions about how certain equations behave. He wasn't yet prepared in philosophical questions about the nature of numbers, but his work led him to come up with his own definition of real numbers. So he had his own thing going on, and he came to the same conclusion, which is strange because not many people come to the same conclusions this early on. Well, I guess they didn't have that many things to work with at this time. Real numbers were starting to get popular, I guess. In early 1872, Dedekind and Cantor independently published their results. They had both done something radical. They redefined the number line, right? So the counting numbers are not the only things anymore. Real numbers are any number in between it, okay? And you have to accept it now, or else. Or so they thought. Before their papers, mathematicians had assumed that even though the number line might look like it was a continuous object, if you zoomed in far enough, you'd eventually find gaps. So that's why we have that cut joke. Take the stretch of numbers, the stretch of the number line between 0 and 1, it contains infinitely many fractions. For any two fractions, you can always zoom in and find one, you can find another one between them. But no matter how much you zoom in, there are certain numbers, like square root of 2, that you'll never reach. These are the gaps. The infinity is broken. So they thought. So they had thought that irrationals were gaps. You could not get there because by definition, you could not reach something that does not terminate. So that's why they didn't take it too seriously at all. In their 1872 paper, though, Cantor and Dedekind had found a way to construct a number line that was complete. No matter how much you zoomed in, on any given stretch of it, it remained an unbroken expanse of infinitely many real numbers, continuously linked. Okay? Suddenly, the monstrosity of infinity, long feared by mathematicians, could no longer be relegated to some unreachable part of the number line. It hid within its every crevice. So now they put infinity everywhere, literally, right? It's there, which is kind of funny to think about it. Hey guys, my thing's better because I used it. Oh, and now you have to use it too. What? I deny this. I will not accept this. Oh, okay, get wrecked, nerd. You're gonna use infinity anyway. That summer, both Cantor and Dedekind spent their holiday on the scenic lakefront village in Gersau, Switzerland, where they crossed paths for the first time and took a long walk together to discuss their ideas. Look at that. That looks beautiful. I would want to be here. I would talk math here. I would say, hey, let's get a crepe and talk about like 2 + 2 is equal to 3. That looks so pleasant. Man, maybe being European is probably like more fun. All of them are asleep right now, so I wish I could probably like talk to them about this. But you guys have like such beautiful like architecture and sceneries and stuff. I'm American, so instead of this, we get Walmarts everywhere, which it's its own kind of like blessing, but you know what I mean. So, to any spectator, the two men strolling along the lakeshore would have seemed an odd match. At 27, Cantor was tall, broad-shouldered, and boisterous. He reveled in attention from his peers, but beneath it all, he was deeply anxious about how they perceived him. So Cantor, he was self-conscious. It made him work. It made him work hard, trying to publish quickly and often. Dedekind, on the other hand, was 13 years older than Cantor, but much shorter and more reserved. And he shared none of Cantor's urgency to publish. In fact, over the course of his life, he would publish relatively little. So, I'm going to look up how many publications did Cantor publish. I suspect he probably did the grind set mindset. What articles, how many publications did Cantor have? In a world of AI, it's really taking its sweet time trying to figure it out. The exact number cannot be specified. Brilliant. I might suspect more than one. Who would have thought? Let's see. Well, he's got like a few. A few of them are books. A few of them are research papers. Close to 20 to 30. That's a pretty good number. Well, what about Dedekind? He also doesn't have a specific number, but more than likely it's less than that, like 10. If it's 5, I'm gonna go crazy. Let's see. It looks like there are only like 3 significant works, other than like other concepts and stuff. The Dedekind cuts and Dedekind domains. So if he published like 3 main things, I mean that's baller, I guess, but not a lot. So that's okay. So Cantor was very much in the I need to grind set this mindset and get stuff done, and because if no one takes me seriously, then I'm gonna actually lose it. But Dedekind was like, hey man, I'm doing my own thing. I'm chilling. I guess. But they hit it off at once, right? In the letters they wrote each other, both reminisced again and again about the beautiful days spent discussing math by the lake. They found in each other a partner, a friend. They would not last. Oh no. So right here is when they met, and at some point something happens, because now they're in the talks. You might suspect, how does he end up cheating? How does he end up taking work and credit? That's, you know, if your friend shows you like their cool assignment, then they would just they would, something irks you to be like, hey, maybe I could just steal that, I guess. And in pursuit of a story, ever since he can remember, Damien Goose has deeply cared about the rules. In 2008, when he was 18 years old, he and his family moved from Germany, where he'd grown up, to Argentina. So this is the author. I don't really care about this bit, actually. So yeah, he was like, okay, I happen to do stuff. I'm a mathematician and I'm doing podcasts now. Haven't we all? So let's go ahead and skip this and go over here. The true story was that Cantor wasn't a lone genius. He had a partner for at least he had a partner at least for a time. When Cantor met like-minded mathematicians, he was known to court them eagerly. He wanted to show up at a collaborator's residence at daybreak, excited to discuss some new idea he'd had. Sometimes waiting for hours until they woke up. That's kind of cringe. Nowadays, if anybody does that, you get a restraining order. But I guess it was cooler back then, so that's pretty cool. Let's see. So it was with Dedekind after the 1872 encounter in Gersau, Cantor took every opportunity to ask the older mathematician for advice. In November 1873, Cantor began an exchange that would forever alter the course of human history. "Allow me to put a question to you," he asked. He wrote to Dedekind in a hastily penned letter. "It was a certain theoretical interest for me, but I cannot answer it for myself. Perhaps you can." Cantor had found an outlet for a zealous drive his father had instilled, the infinite nature of the number line. He had a very strong sense of the mission, he said Jose Ferrieros, a historian, a philosopher, mathematician, mathematics at the University of Seville in Spain. He was convinced that the introduction of actual infinity was going to change not only mathematics, but science in general. To Cantor, this kind of infinity didn't contradict God's supremacy. It had meant that rather than being remote and unknowable, God was everywhere, residing in all things, which is a cool outlook to think about. So I can appreciate that. That's kind of cool. So instead of being all like edgy about like, oh, it's the end of the world, you're learning blasphemy. It's like, hey, Jesus, man. he's everywhere, which is, in this context, the analogy would be true. I thought that was cool. So he began studying the real numbers as a single infinite package, asking questions no one had thought to ask before. But there is a difference between the infinity signaled by the 3 dots in 1, 2, 3, ... and the one built into mysterious continuum on the number line. In other words, were there more real numbers than whole numbers? Yes, in fact. The question seemed nonsensical at first. What do you mean there are infinite sets of different sizes? Well, you'll never believe it, but my namesake suggests otherwise. He asked Dedekind whether the 2 sets of numbers he could put into one-to-one correspondence, a pairing of real numbers with its own distinct whole number. He'd managed to do this, he wrote, for a different set. He proved that the rational numbers, numbers that can be written as a fraction, could be assigned a unique whole number, without leaving any numbers left over. That is, even though there appear to be more rational numbers than whole numbers, the 2 sets are actually the same. Both were therefore what mathematicians would later call countable. So that is the counting, the diagonalization method, right? That he uses. So if you can count them, then it is countable. Duh. Which means it's a standard infinity. But if it's uncountable, it's the next level infinity, right? Power scaling. But Cantor couldn't figure out how to compare the whole numbers to the real numbers in the same way. Dedekind quickly replied that neither could he, but that he'd worked out proof that the algebraic numbers, the numbers that you get a solution of algebra problems, could be counted. So irrationals, not yet. We haven't gone to transcendentals yet. I would not have written all this, Dedekind wrote to Cantor in closing, if I did not consider it possible that one or the other remark might be useful to you. From there, the mathematical volley continued. Energized by Dedekind's progress, Cantor spent the following days plugging away at the remaining question, the real numbers. Could he finally show that, unlike the algebraic numbers, that they are bigger infinities than the whole numbers? On December 3rd, 1873, he wrote to Dedekind that he thought he'd finally succeed. But if I should be deceiving myself, I should certainly find no more indulgent judge than you. He laid out his proof, but it was unwieldy and unwildly convoluted. Dedekind replied with a way to simplify Cantor's proof, building a clear argument without losing the rigor or accuracy. Meanwhile, Cantor believed, but before he received Dedekind's letter, sent him a similar idea for how to streamline the proof, though he hadn't worked out the details the way Dedekind had. Cantor considered what he had in hand, 2 sets, both infinite, but one somehow larger than the other. The implications were revolutionary. He began to dream of not only one infinity, but an entire hierarchy of them. And if infinities could be so concretely compared, then they had to be real, not just figures of speech. His proof, he realized, had the potential to shake the math world to its core, but not without angering some of its most prominent figures. So this is where we get into some drama, right? Not only did he have like solid evidence now, he thinks that he's still gonna piss people off, which understandably so. They've been talking about for infinity as an idea for like the longest, and now all of a sudden he's like, hey guys, it's real, and believe me, and everybody, we're gonna do this now. The implications would be too drastic. So this is where the drama comes in. He needs to be drastic on how he's gonna deliver this idea without pissing the fuck out of people. So let us find out with this real quick. And give me just a second to breathe. So, one of those figures was Leopold Kronecker. So, if you guys have ever done the Kronecker delta before, that Kronecker, right? So, matrices, identities and stuff like that, the Kronecker delta, that Kronecker. So he's a mathematician, an ideologue who detested infinity. He did not like this thing. He didn't believe in the numbered lines packed nooks and crannies. He didn't believe that the number lines packed nooks and crannies. According to mathematician Ferdinand von Linnemann, who proved that pi is an algebraic, you could never pose an ordinary algebra problem where pi is the answer. Okay, well, yeah, that is. Linnemann proved that pi is an algebraic. Cool. Kronecker once told him his work was worthless since such transcendental numbers did not exist. So he roasted the hell out of Linnemann, and he might just humiliate him, Cantor soon, right? He might give him a big old womp womp. Hey, you're a little stinky, and you smell, and your proof is stupid, even though it's right. Let's find out. Kronecker was also a major gatekeeper in the world of math. He was on the editorial board of Querel's Journal, one of the world's preeminent math publications, and he never hesitated to use his enormous influence to push his reactionary agenda. Often, he would decide which results would reach the mathematicians quickly, or at all. So, he was in charge of these journals, one of the most prominent ones. That's kind of rude. So, Cantor, after discussing his work with his mentor, Karl Weierstrass, Weierstrass is also another important guy. All these important people real quick. So, yeah. Wanted to publish the findings in Querel. There, he figured he'd be able to bring infinity into the mainstream, to reveal the mind of God to the entire world. to become a shining star in math's horizon. I actually really like this article. This is very well written for what it is. It's talking about math in a very very cool way, and it's tying in all the characters together. So it's like really, really cool. So I'll probably look more into this journalist more and appreciate the article. Cantor's sense of mission, the secret voice within him, began to swell. Right? He wants to do something. He needs to do something. Do it. Publish. Go. Do the thing. Do the thing goodly. Don't do the thing badly. Cantor had a good relationship with Kronecker, but several years before, Dedekind had beaten Kronecker to a major result, and Kronecker's dislike for him was well known. He pissed him off. If Cantor submitted a paper co-authored with Kronecker's nemesis, a paper that openly declared that multiple sizes of infinity existed, it might never get published. So he made two decisions. The first was to build a mathematical Trojan horse. Weierstrass, who had been most excited about the proof of that algebraic numbers are countable, he would later use that to prove a theorem of his own. So Cantor chose a misleading title that only mentioned algebraic numbers. Okay. But he saw that proof, Dedekind's proof, as a decoy, a wedge he could use to pry open the forbidden gates of infinity. Writing his paper, Cantor put the proof into about algebraic numbers first. Below it, he added his own proof that the real numbers cannot be counted. Dedekind's simplified version of it, that is. So, the idea of the algebraic numbers, all the cool numbers like square root of 2, that one's algebraic. But pi or e, they're transcendental because there's no way to represent it as, let's say, a fraction or a square root or anything like that. That's what that's about. Except he uses the idea of algebraic numbers first before he starts talking about reals, because algebraic numbers, transcendental numbers, are a part of the infinite set. You know, there's infinitely more irrationals than there are rationals. So in this case, he was going to use that to get him inside of the publication, starting with something smaller. So, where are we at? So below it, he added his own proof that the real numbers cannot be counted. Dedekind's simplified version of it, that is. Cantor downplayed his the second section's true import. He deliberately chose a wording that could not sound suspicious to Kronecker and all who hated infinity, Goose said. So, what did he say? He probably said something where like, also, this is cringe, and this is, infinities are lame, except this particular kind is pretty neat. Right? Probably like that. He's kind of playing coy with the idea of it. So, Cantor's second decision was to claim full authorship for himself. He carefully erased every trace of his collaborators' contribution, including stray uses of terms that anyone in the know will recognize as Dedekind's. In classic Cantor fashion, he slapped the paper together within a day and submitted it to Krell. The following morning, Christmas Day 1873, he posted a letter to Dedekind, letting him know that Weierstrass had convinced him to publish. As you will see, your remarks, which I value highly, and your manner of putting some of the points were of great assistance to me. So he's saying, thank you so much for letting me think about these things. Now, this actually does have a different turn real quick. So let me summarize what we have so far. So, we have Cantor discover that with Dedekind's research that infinities are practical and he can describe it better. And with that, he's able to sell it to other mathematicians in an article. But to do that, he has to downplay some of it. So, in that regard, there's probably going to be a lot of collateral that comes from this. And maybe even Kronecker might get pissed off discovering what it was really about. So, that's probably my guess as to, because this is around this time that I stopped reading this article. I'm gonna find out exactly what he means, but right now that's what we have. He published by subverting expectations, and pretty soon, he's either gonna piss off 𝖘𝖘 because he kind of stole his work and shit on it, or he's gonna get found out by Chroniker, and after the fact, he's gonna get, scrutinized to some extent. I think that's all the case. So, I mean, the foreshadowing in the beginning implies that they are not friends anymore. So, even though they're co-authors of Infinity, he only authored himself, 𝖘𝖘, which is a bummer. So, let us continue. Let me go ahead and take another quick drink. Okay. So now, hello there. Do you like infinities? I'm covering an article about infinities and how somebody plagiarized the idea of it to popularize it. And now we talk about infinities, and it's really cool. So hello there. Hope you stick around. So let me go ahead and get started back onto the article. So we have 𝖘𝖘 is the guy that published, and he talked to this other guy called 𝖘𝖘, and 𝖘𝖘 stole 𝖘𝖘's work. He kind of plagiarized it, and he's selling his authorship without crediting 𝖘𝖘, which is a very not cool thing to do. So we'll continue reading and seeing what happens next. But he's published the paper, and the whole point of the paper is that, like, the journal that it comes from, the guy doesn't like him. Like the guy, the owner, or the co-author, or the gatekeeper, he doesn't like infinities, so he's about to yeah, don't worry. Basically, somebody stole credit, and there's another guy that hates that study in the first place. So to actually get it published, he had to basically dunk on the original guy who did help him with his research to make sure that his actual research, which is still relevant to that thing, can actually get published. Because the guy just didn't like the subject at all. That's really what it is. So, did the 𝖈𝖊𝖆𝖆𝖈𝖎𝖆 on him. He just did the whole switcheroo bit. Hey, can I see that? Can I borrow your homework? And he just publishes it without letting him know. So we're about to see what happens next. The first evidence of 𝖘𝖘's deception was uncovered in the early 20th century by another great mathematician, a German mathematician. 𝖈𝖗𝖊𝖉𝖎𝖙𝖘 was a 𝖘𝖘 acolyte. She would often wax poetic about his mathematical precedence, and she liked to tell her students everything was already 𝖘𝖘. So she was a fan. She fangirl. And she stanned him, if you will. No, it's okay. Just enjoy the beats while we go. I don't understand some of these either. In 1930, she was collecting all of his mathematical work into a 4-volume publication, when she happened to find on some of the letters he'd kept from his correspondence with 𝖘𝖘. She partnered with the French philosopher Jean 𝖘𝖔𝖈𝖎𝖎𝖙𝖘 and gather and publish them as well. It had been over a decade since 𝖘𝖘 and 𝖘𝖘 had died. Oops. Noether and 𝖘𝖔𝖈𝖎𝖎 spent the next few years tracking down letters from 𝖘𝖘's estate. In 1933, after Adolf Hitler's rise to power, Noether, who was Jewish, fled from Germany to the US, where she died 2 years later from cancer. Okay, that's actually more interesting than I think right here. So after these guys died, the people that were like picking up the pieces and like making a fan club, Hitler shows up. He's like, hey, let me do some Nazi stuff. No, big no. And then so Noether leaves, and then she ends up dying. But 𝖘𝖈𝖎𝖎𝖎 completed the project in 1937. That's kind of neat. The correspondence as it was presented in the book, it was strange. It began with a flurry of letters starting shortly after Cantor and Dedekind met in 1872. 1872, they met and they said, hey, I like your math, you like my math, let's be friends. But they end up not being friends. Why? The letters from Dedekind's estate included only those that he'd received, not ones he sent to Cantor. Okay. Then the correspondence suddenly ended in January 1874, and several years of silence followed. When the exchange resumed in 1877, Dedekind's own letters to Cantor now appeared as well. Dedekind was had apparently decided to keep a copy of everything he was sending to his fellow mathematician. That's kind of smart. There was also a note Dedekind seemed to have written to himself after he saw Cantor's 1874 publication in Krell. In it, he recounted how he'd sent Cantor the first proof of in the paper and the revised version of the second, only to see them both appear almost word for word. That's plagiarism, guys. That's not good. Appear word for word in print just a few months later under Cantor's name alone. Dedekind never went public on this claim, and Noether and 𝖘𝖈𝖎𝖆𝖎𝖙 didn't comment on it. I think for them it was very conscious. It was a very conscious decision not to say anything, and just let the letters speak for themselves. Said 𝖈𝖎𝖎𝖙𝖘, the historian in Seville. That was the honor code at the time. No one else called attention to it either, at least not in print. The earliest biographies of Cantor, written by his mathematical disciples, simply lauded at his genius. Decades later, historians such as 𝖈𝖗𝖊𝖉𝖎𝖙𝖘 revisited Cantor-Dedekind exchange. Grantan-Guinness tried desperately to track down the letters Dedekind had sent to Cantor in 1873. The ones that might prove Cantor's wrongdoing. They had supposedly been left with Cantor's office in the University of Hull after his death, but now they were nowhere to be found. Most likely, Grant and Guinness concluded they had been lost during World War II, or in the destruction that followed once America and Soviet forces occupied Hull in 1945. Interesting. Without the letters, Grant and Guinness and his contemporaries decided to not accuse Cantor of ethical misconduct. Some decided he'd acted with Dedekind's permission. Others excused his choice since he'd begun the exchange that had first come up in the first version, and the first version of the more significant second proof. But when Goose learned of the history while working on his podcast in 2024, he was outraged. He could only find one piece of writing that explicitly discussed Cantor's wrongdoing. In 1993 paper, 𝖈𝖎𝖎𝖙𝖘 accused Cantor of stealing and publishing Dedekind's work without credit. But other Cantor's biographers immediately pushed back on 𝖈𝖎𝖎𝖏's narrative. So very interesting. Hello there. We're breaking down why plagiarism is wrong. Nice to meet you, Sandfakin. Sandfakin? Yes, welcome to the set. I am breaking down an article about how somebody stole credit and didn't give credit. I'm a math Vtuber. I like to talk about math stuff. And today we're talking about plagiarism, about the idea of infinity, and why plagiarism is bad. So, hello, welcome in. Right now we're in the story where they've been long dead. Did it explain why Cantor copied him yet? It did, I think. So the whole reason why he did is because the ideas of infinity were not accepted at the time. And so to get his Trojan horse through, he has to sell it as something different. So imagine if, let's say, introducing your friend to K-pop, and the first thing you say is like, hey, do you like pop music? I found this cool band in Korea, or, you know, this cool group in Korea. Take a watch, you know? But also say that, like, I don't know, maybe like J-pop or something like that. Also, J-pop culture is toxic as heck, and K-pop is better. It's like, what? So it's like that. He's trying to sell it to them, and he does get it published, but he does it without credit, right? The entire reason why he got in this field and was able to get some good results was because of his friend 𝖘𝖊𝖘. But 𝖘𝖊𝖃 did the slimy thing, which is, I mean, understandable, I suppose, to try to sell it, so that he can actually get some credit for it without getting scrutinized for it. So basically he said, my thing's better, this other thing is really dumb, but this one cool thing happens when my thing, but the other thing is dumb. And also I made it all myself. This is like my credit. So I did it all myself and I get a gold star. Kind of like that. That's the idea here. So hopefully all the people left now, they're picking up the pieces and they're trying to find out what exactly happened. Because they knew they were friends once, and he published the article, but they don't know the actual feelings behind them, because they knew that they met, but they don't know why he wasn't credited. So yeah, so this becomes a long goose chase for the longest, which his name is Goose, so that's kind of funny. He could only find one piece of writing that explicitly discussed 𝖘𝖊𝖃's wrongdoing. In a 1993 paper, he accused 𝖘𝖊𝖃 of stealing and publishing 𝖘𝖊𝖃's work without credit. But other 𝖘𝖊𝖃's biographers immediately pushed back on 𝖃𝖃's narrative, arguing that it was too extreme an interpretation of what had happened. So everybody after the fact, because you get, basically when you are important and make something cool, you get a giant fan club. And all the people in your fan club don't like it when you diss them. So they diss back. They say, nuh-uh, your guy is dumb. And they say, no, but he stole credit. Nuh-uh. You don't know that. I don't think you know that. Prove it. Which is funny for a mathematician to say. So, besides, without 𝖘𝖊𝖃's missing letter, there is no real proof of the supposed crime. Only 𝖘𝖊𝖃's note, written afterward. How could anyone be sure of its claim was true? It remained an obscure debate among historians of mathematics, and 𝖘𝖊𝖃's lone genius mystique endured. Goose wanted to tell the real story on his podcast, and to back it up, he saw only one way to do that, but it was a long shot. They were always saying the letters were lost after the war, he said. That bothered him. There was a lot that was lost without any doubt, but it doesn't mean that nothing else survived. Okay. Many good historians had searched for the letters and come up short. Goose had started his research, but could all the experts have missed something. Let's find out. So this is a new section, and we have quite a bit to finish right here. Oh, that's a lot. I might finish half of this, and I do want to move along to doing something pretty neat, but I like cliffhangers. So I'll probably finish 2 more paragraphs, and then we'll wrap it up maybe another time, because right now I do want to play some games, and I am tired. It's late at night for my end, so I'm not sure if anybody's still interested in like thinking stuff tonight. I'll do like a less thinking thing soon, so we'll transition pretty soon here, don't worry. But for right now, we're just gonna finish a few more things, and we're gonna be like, but what happens next? What happens next? So we'll finish soon, so don't worry. Okay. A lonely existence. So, 𝖘𝖊𝖃's paper in Krell didn't make a huge splash, as mathematicians largely missed what he'd hidden between the lines. Oh. But he'd landed his first blow in what would become a lifelong assault on his mathematical status quo. He published a proof in Math's foremost journal that infinity came in different sizes. That is a baller title, right? It would eventually force mathematicians to rethink the foundations of the field, to decide on its most fundamental rules and their consequences. Meanwhile, 𝖘𝖊𝖃 stopped replying to 𝖘𝖊𝖃. But my friend, I thought we were friends. This is heartbreaking. For nearly 3 years, they didn't correspond at all. Then, for reasons that aren't entirely clear, 𝖘𝖘 cautiously re-engaged. He hit his DMs. First, he ghosted him, and then he hits him in the DMs later. But this time, he kept a draft of every letter he'd sent, a record for safekeeping. Oh, what a cautious man. So he screenshots everything before the DMs could leak. Okay, this is a dumb analogy. So that's the idea going on here. He, after ghosting 𝖘𝖘 for a while, then he talks to him again. But he records everything, which makes sense. The two began discussing infinity again. Cool. 𝖘𝖘 was planning to follow up with his on his work on infinity. Was planning to follow up on his work on infinity's many sizes, and he wanted advice. His letters were now more supplicating. His papers were more supplicating. 𝖘𝖘's warrior. Okay. But the correspondence was productive, and 𝖘𝖘 soon submitted a new, more daring paper to 𝖘𝖘, this time without a disguise. So 𝖘𝖘, he started out by making a fake thing, and then now he's getting brave and saying, actually, infinity is cool, guys. It's trendy. We can do it. Chroniker revolted. Okay, that's the drama I want right now. So Chroniker hates infinity. So let's find out what happened here. He used all his influence in the Berlin Circle to delay the review process as much as possible. But after several months, Weierstrass and others interceded on 𝖘𝖘's behalf. And the paper eventually appeared in the journal. Ooh, own. Get owned. People don't say that anymore. Get owned. Get wrecked, nerd. I just posted it on my Reddit account, and I got karma off of that, nerd. You can't ban me. Some kind of like mod speech, I suppose. Once again, ideas from 𝖘𝖘's letters to 𝖘𝖘 appeared in the paper without credit. Once again, 𝖘𝖘 cut off their correspondence. So he's just plagiarizing off of 𝖘𝖘. That's pretty messed up. 𝖘𝖘 would perhaps come to regret this break with one of his only intellectual allies. He'd been struggling to turn the mathematical backwater of Hall into the epicenter of the field that was growing out of his work, set theory. So he's just playing with him. That's so messed up. His best bet for achieving this was to hire 𝖘𝖘. In 1882, he tried to recruit him as if nothing had happened. 𝖘𝖘 politely declined. That is so sad. So, I mean, think about it, would you? You steal all of his work, all of his credit, and then all of a sudden you're coming back and saying, hey, I can get you a job doing the thing that I stole from you. Kind of fucked up, I'm not gonna lie. That's not nice at all. Okay. As 𝖘𝖘 continued to publish results on infinity, yeah, this is toxic. This is the drama that like people don't talk about in like math stuff. It's like, come on, you can definitely describe the nuances. It's not just all like 2 + 2 = 4. It's more like, this guy stole my research and he's a bastard for it. And then this other guy, he's also petty as hell, so he stops publishing anything, or he stops researching anything just because I'm in it. It's like, I mean, that's the egoism and like science, I guess, but it's just so funny. It's so funny. This is great. To be fair, I mean, I have my gripes with certain subjects as well. Like, specifically, I do not like statistics, and I've gotten to not love space stuff. I've grown wary of space things because I've met many people that have like ruined it for me. So I don't say I spite it, but I wouldn't want to work with it. If you like stats, then that's on you. I'm just saying, okay? It's not rigorous. It's a bunch of magic math voodoo, and you guys make numbers appear out of nowhere, which doesn't have, to me, any, like, I don't understand why you guys use it. You know? Chi squared You want a small p-value? You're supposed to have a big p-value. The whole point of a big p is because you can brag about it. Isn't that how that works? I don't know. uh, Clearly, I don't know what stats does, but everyone has their gripes with subjects. So seeing these guys do it is very like human. So as much as we think that they're old, they're not. They're like still petty people, you know? It's so funny. The math wizards, they're just casting spells at each other, you know? They're probably like researching their thing just to say, hey, I have a counter argument because you're stupid. You know how much spite that thrives in you? You know how much research that takes? How many years it takes to like research their field and then just find a counter example because you hate them so much? That's so like petty, and I love it. This is the melodrama that needs to exist, you know? They should make a TV series, a telenovela or something like that. That'd be hilarious. Okay. As Cantor continued to publish his works on Infinity, Kronecker worked to turn the mathematical community against him. He called Cantor a corrupter of the youth. Dang, he's going all classic Greek on him, you know? And a renegade. Holy smokes. When Cantor trying to leave Hall, applied for a position at the most prestigious University of Berlin in 1883, Kronecker, a professor there, blocked his appointments. Oh no. Other mathematicians, including some of Cantor's friends, began to discourage him from publishing too. Oh my gosh, it was all petty. This is like crazy like petty. Oh my god. Cantor took all of this resistance personally. Dude, oh, they're ghosting, blocked it. They have a group chat without him, and they're making fun of him, and they're coming back and saying, "Hey, you don't belong in our group." This is crazy. Cantor took all of this resistance personally. He has this longing for approval, Goose said, but it's very nature of doing things differently from everybody else that they won't like it. In 1884, Cantor was hospitalized due to a major depressive episode, haven't we all? Over time, he grew more and more isolated. There was a pattern, Ferrios said. Many of his relationships with his colleagues ended up on bad terms. It's just a modern day Discord drama. Dude, this is so petty. So, not only do they ghost him, he gets depressed. He gets, like, psych damage from this. And then he's like, okay, I gotta take a break, guys. Many of his relationships ended up on bad terms. I mean, like, that's so mean. They're the popular kids, and then they just making fun of him. But he did something really cool once. He's the star athlete. He's the MVP. Or something. I don't know. What other analogy makes sense? Eventually, Cantor fell victim to the opposition his father had warned him about. When he was repeatedly denied the academic posts and the honors he felt he deserved, his sense of mission gave way to resentment. That's his origin story right there. His villain origin story right there. His depression returned, and he was hospitalized several times over the next 2 decades. In 1917, he was finally committed to a sanatorium, where he wrote his wife regularly, begging her to let him come home. He died the following year. That's a bummer. That sucks. Cantor had been forced to the margins, but gradually his ideas began to gain traction amongst the new generation of mathematicians. They saw in Cantor's work the potential to rewrite all of the mathematics from the ground up. So this guy got shunned because he was like too different, and then all of a sudden everybody's like, oh, this actually is pretty cool. This sounds like a lot of like trends, to be honest. Like, yeah. And then it becomes popular, and it's better than everything else that everybody else ever done. Yeah, that makes sense. But I really like the pettiness of like, you can't join our club because I said so, and I'm gonna make everybody like not talk to you. That's so funny. Sad, because I mean, genuinely, this is like sad, but funny. Modern day. I sure hope there's no one in the group chat with me that talking behind my back. That'd be really bummer. Okay. I just realized. I think it was because of my cats. My cats have been in here, and they like to scratch my door, and they want in. You know, I'll pet my cats. They want uppies. I'll let them do it, but they can't do it unless I say so. Anyways, let's see here. A lucky find. This is probably about the part where they find the letter. Goose too was looking to do some rewriting. In his 2024 podcast, he covered the conflict between Cantor and Dedekind. But having failed to unearth any new evidence, he found it difficult to shift the debate. He turned to other projects. He still couldn't let the story go. So, he continued to dig for clues about the lost letters in his free time. I don't think there's one book left that I don't have, he said. He tracked down original sources and scoured university archives whenever he could. I'm talking really about primary sources that are mentioned once in a single line in a single article. That kind of stuff. Okay. That's how, in the summer of 2024, he stumbled on the partial scan of what looked like a letter from Dedekind to Cantor. It was on a webpage titled Gregor Cantor 𝖈𝖕𝖎𝖙𝖘. Sure. And George Cantor's Association. It's a group of people trying to keep Cantor's memory alive, Goose said. The letter was from 1877, long after the conflict, so Dedekind's draft of it was already in the historical record. But there had never been any record of the copy sent, never been any record of the copy he'd sent to Cantor. Goose tried contacting various members of the organization, but got no reply. Months later, he returned to the webpage. But this time, he noticed that below the scan, the site mentioned 2009. A 2009 donation of letters from an heir. He tracked down who that heir could possibly be, and after poring over many family trees and other documents, he finally came across Dr. 𝖘𝖔𝖈𝖎𝖎𝖙𝖘, Cantor's great-granddaughter. Okay. Who appeared to be living in Hull. Very interesting. When he called her, she told him that she knew nothing about mathematics. She was an archaeologist, in fact, but that she wanted to make sure letters were possessed, that she possessed, available to historians for study. She had given them to the University of Hull, today formerly known as Martin Luther University Hall, Wittenberg. Interesting. Excuse me. And they'd ended up with the president of the Cantor Association, a math professor named Karen Richter. Goose tracked Richter down, arrived to her office in March 2025, opened a thin blue binder she handed him. So we go back to the very beginning of the story, where we find out what's happening with this thing. He had been expecting to see the latter letter from Dedekind that he posted on the Cantor Association website. It would be like his other pursuits of original sources, a good way to verify what's already been known and perhaps glean into new insights. But here before him was the letter he'd been hoping to find for over a year. He was sure of it, although Dedekind's meticulous, ornate handwriting was somehow even more indecipherable than Cantor's uneven scrawl. Goose could see that the pages were peppered with the phrase 𝖈𝖗𝖊𝖉𝖎𝖙𝖘, algebraic numbers. And at the bottom, unmistakable, was the sign-off. With warm regards, your most devoted R. Dedekind, 𝖈𝖗𝖊𝖉𝖎𝖙𝖘, 30 November 1873. So he did, in fact, write a letter. These must be it. Oh, that is definitely some fancy writing. Look at that. It looks like the Declaration of Independence. I cannot understand this. But it's okay. Did Richter even know that she had what she had? He asked for scans. Richter said she'd think about it. On the train ride home, his second 5-hour trip on the day, Goose contemplated the discovery he was sitting on. He knew that the situation was delicate. He experienced German's mathematicians' dismissiveness when he brought up 𝖘𝖔𝖈𝖎𝖎𝖙𝖘 of Dedekind. Pride is something that Germans don't often feel comfortable with, he was said, but we are proud of 𝖘𝖔𝖈𝖎𝖙𝖘. Hello, I am Atomic, and I thank you so much for the follow. I'm breaking down how 𝖘𝖔𝖈𝖎𝖙, the guy that brought infinity to the public, he plagiarized and stole credit from the other guy, and then he still ended up not being popular after plagiarizing because he was talking some wacky stuff and they ghosted him, and they made him unpopular, and he basically died of depression. So infinity was cool, and then it became rad with the kids later. So that's what we're covering in this article right now. He had a best friend, and his best friend he stole credit from, and his friend ended up ghosting him and then talking to him again, and then he plagiarized again. So very normal stuff in the field of research. So pretty interesting. This article is, I'm almost done with this one. This one's actually pretty interesting. I'm probably going to finish this one out actually because I'm so invested. Yeah, shoot, like 𝖘𝖔𝖈𝖎𝖙𝖘 is the guy, the main guy. He was like a recluse and kind of a nerd, if you will, like a dork. Unpopular, okay, he was smart. Everybody's smart in this, but like the idea is that he was like breaking down infinities, but he really wanted to be published. And the other guy he talked to, Dedekind, a much older dude, he had his ideas down, but he never really published because he didn't feel the stress for it. So he just kind of kept it in his like head. And since the two met, they got to talk about the ideas. Then when 𝖘𝖔𝖈𝖎𝖙 got the opportunity to talk about his thing in an article, in a publication, the people would not have liked the article because it talks about infinities, and infinities at the time were not taken seriously. So he needs to sell infinity in a way that is approachable to many people. So he uses part of it for a proof of something else, and then later on he just comes out with the entire thing. So first time around he went okay. He kind of broke his friend's heart because, you know, stealing isn't cool. Then what do you call it? Then he tries it harder this time. He's like, hey guys, infinity is really cool. It's not just lame. And then he ends up getting shunned by everybody because it was too radical, right? Infinities are in fact not cool at the time, and they're not ready for that. So he gets depressed. He gets shunned from the like professorship and all the research clubs, and basically he falls into a depression fit and dies. When haven't we? So, but again, his research made sense. So all the people afterward, they're like, wow, this is so cool. I can make infinity do anything. Whoa. And then they end up picking up after him. So, but he cheated. He sold the thing up first, and then he, yeah, that's pretty interesting. And then everybody was pissed at him at the end. He got the horrible death and he gets recognized, Chris. Dude, this is so funny because genuinely, like, his legacy, like, again, the whole thing with the bust in the beginning of this article is talking about like how cool he was. He revolutionized all this new mathematics. And then at the time, dude was going through it. Oh man, this guy was like, he was not having a good time. So he came up with like the best idea ever, but he talked to somebody else. They got the idea down. He takes it without credit because he wants to get ahead of the gun. And then later on, his friend stops talking to him. Then he tries to go harder into the infinity stuff. And then everybody ignores him or starts ghosting him. And then he falls into depression. So he didn't get popular because I think he was just, his delivery here was kind of bad. I mean, really, think about that. Like, I think there was definitely a way he could have like done all this stuff without being so bad at delivering it, if that makes sense. He could have consulted Dedekind. He could have done this. Yeah, this is totally studying. This is like, I mean, what, math research, math history? I don't know many math history at all. I never took a math history class. I just happened to find this article because my name is Aleph, and I'm alephmuvt. I'm a Fractal Vtuber. I have infinity on my freaking belt. So, yeah, I happen to be liking infinities and stuff like that. So I happen to find this article, and this, what do I call this? My dads, but they hated each other. Oh, this is great. Oh, this is so funny. You have relationship counseling. Well, mommy and daddy are fighting, and I don't know where I fit in all that. Oh, this is great. So, yeah, that's the TLDR. We're almost done with this article, so let's see. We have a bit more things. Oh wow, that's almost done. Holy smokes. Okay, wait, where were we at? Back here, right? Oh man, this is so good. So yeah, that is, you got the synopsis. So, or the modern filtered lens of it. You know, instead of it being cool and stoic, like, oh man, I'm so edgy and I'm gonna discover mathematics. I'm gonna do things all by myself, and I'm so cool, and everybody will recognize me because I'm so cool. And it's like really like cringe. And really cringe is like the biggest downfall to this guy's like history. I mean, don't get me wrong, Cancer is like a brilliant person, and I will probably respect him because, I mean, yeah, we do lots of things with his name on it, so, but it's just funny that like the one thing is just like he really tried to sell it, and he really didn't sell it very well. Oh, that's so sad. It's great. Alright, are you guys ready to get back into it? Let's go ahead. Let's see. We were... Richter... So he was talking about the papers, and the person, like the great-granddaughter, is Richter here. So she is an archaeologist, but she is the related. And then this here... Okay, on the train ride home, we're continuing back with Goose, because Goose wanted to research this stuff for his podcast. Which... You know, I guess that sounds cool. That sounds like a nerd thing to do. Guys, I have a podcast, and I gotta really learn about this. This is like proper journalism as opposed to like, you know, shit posting. So sure, good on you, Goose. I appreciate that. On his train ride back home, his second 5-hour trip of the day, Goose contemplated the discovery he was sitting on. He knew the mathematicians were delicate. He had experienced German mathematicians dismissive. Yeah, okay, we cover this. They were dismissive about how they treated him, so they're like, yeah, we bullied him, we didn't accept him into our group. That's Russian. We didn't like him, and then now he's dead. It happens. Okay. Pride is something Germans don't often feel comfortable with. Okay. But we are proud of Cancer, and it'd be hard to find a bigger Cancer fan than Richter, which is the granddaughter, and she hadn't seemed eager to share the scams. I wonder why. When he called Richter's phone number 2 days later, his hopes sank. It was no longer in service. Okay, what? So the granddaughter lets him like explore the project for a second, then she ghosts him? This is modern day. This is 2024 when this thing happened. What? How do you tell somebody this, you know? I talked to this lady. She didn't seem really happy to share these letters, so I called her, and her phone doesn't exist anymore. Come on, Demian, come on. What happened here? This is crazy. Oh my god. So okay, not only did Cantor here is like cursed, like anybody's trying to figure out the scope. So not only does his research, his legacy get like tarnished a bit, now discovering this, but also the guy researching Cantor, trying to find the plagiarism, he gets ghosted by the granddaughter. You cannot get funnier than this. Okay, he berated himself for being too polite to pull out his phone in Richter's office and start taking photos. Shit. Yeah, you kind of don't do that. I mean, I guess she's the granddaughter of the guy of the family. Yeah, so but if they're looking for like, you know, stuff on him, I guess that's kind of rude. Dude, that's crazy. He spent the next month contacting everyone he knew in Hall, begging them to find a way to get to Richter. I'm starting to think I'm going crazy, he said. Does she even exist? Finally, one of Richter's colleagues told him when and where she'd be giving up her next lecture. So because she's an archaeologist, so she happens to be doing stuff. He made the 10-hour round trip again in April, and Richter explained that she'd changed phone providers. That's the excuse? Oh, that is such a okay. What? They couldn't do email. Well, this is modern day. Oh no. She handed him a single scan and transcription. It was just one letter, but that one, just the one that mattered, right? Okay, so she gets back to him about this. She was like, "Oh yeah, I put my phone down for a bit, but and then I got busy for a second. Here you go." I don't believe that. This is so like this is melodramatic. I'm getting worked up on this. This is actually funny. Oh man. Okay. Another month later, another trek, and Richter handed over another Dedekind letter. This one was from the summer of 1873. Goose didn't know if he could afford any more of these trips. I'm not rich, aren't we all? It was time he decided to let the world know what he'd found. So then, today, Cantor's renown far exceeds Dedekind. Yes, because Cantor set theory is a thing. Dedekind did some research and defined the number line, but I heard Cantor more than I do Dedekind, so that is true. But both made major contributions in the foundations of mathematics, but Cantor is often credited with wrangling infinity and inventing set theory, the language that all not modern math is now written in. His reputation as one of the history's greatest mathematicians has been bolstered by biographies and popular books. And he is one of the few mathematicians known to people outside of the world of math. Okay. He's a pretty famous guy. There is no English language biographies of Dedekind. Wait, what? There are no English language biographies of Dedekind? Really? His Wikipedia page is a quarter length of the erstwhile of his erstwhile friend. Among mathematicians, largely thanks to Noether's efforts, he retains a reputation as a lesser-known visionary. The more I learn about Dedekind, the more impressed I am. Yeah, Erstville. Close enough. The more I learn about Dedekind, the more I am impressed. Yeah, because this guy was like chill. He was like, "Hey, I have this cool idea. I came up with it first. What do you think about it?" And then this other guy was like, "Oh, that's so cool. That's so cool. Let me get everything about it, and then let me publish it into like a paper and an article. And I'm gonna do it. And but to do it, I need to do this, and then to do that, I need to do this." And so he got a little too excited, and then he's like, "What are you doing, man?" It's so like sad. Dedekind must have been a chill dude. I would have gotten a beer with this guy. Oh man. Cantor though, I probably hang out with him, and then I would unironically have a group chat talking about him. Oh, but that's so funny though. Okay. Cantor proved all of these great theorems, but Dedekind was probably the greater mathematician based. Yeah, he's a real one. This guy. If you ever hear Dedekind, just don't get cut, because the joke is that, yeah. Let's see. The real story behind Cantor's 1874 paper had been sitting in the open for 90 years. And I appreciate you. Hold on. I gotta stop too. I appreciate you guys like sitting out for this. This is like, I had no idea how this was going to go today. And I just thought this article was really funny. And now I got worked up in this. This is hilarious. So I appreciate you guys checking this out with me. This is like funny. If you guys aren't in my Discord already, I do have a ping for that. So if you guys are welcome to join, I have I'm gonna plan my next streams again this soon. This week is gonna be a little interesting because I have more time. So I will make a post about it soon. And then actually the rest of the stream, you guys will see me like model I'll show you the behind the scenes on how I make my graphic for it, and my philosophy for it. So I will be showing, I think Tuesday is gonna be my next day soon. So stay tuned for that. We probably won't be doing an article, but I'll find another one soon. And this is funny. So we'll see what we can do next time. So let's go ahead and write this out. We have a few more paragraphs. We can get this one done. So let's see. The real story behind the 1873 paper has been sitting in the open for 90 years. But it isn't the kind of story people like to tell. Every branch of science needs a hero, Ferrios say. Chemistry has Lavoisier, mechanics has Newton, relativity has Einstein. There's always this one. Only one. But that's always a lie. So really? Because I know Newton's contender was, Kepler. That's not true. Look, Leibniz, I think. So yeah, and the chemistry, Lavoisier. I don't know him. I'm not a chemistry guy, clearly. I might have to ask a friend about that. Who's popular in your field? Who's the most famous person in your field? Yeah, kind of stuff like that. Since challenging the lie, Goose has met resistance. When he shared his discovery of the lost letter, mathematicians have questioned his importance. They're also going to ghost him. Please tell me they ghost this guy. That'd be so sad, and the history will repeat itself. Especially in Germany. So he got shunned in Germany. He's had trouble getting people to see why it matters. The reaction echoes historians' response to Ferrio's paper 30 years ago. But it does matter. Math is often viewed as the science that lives in the safest distance from the real world and its imperfections. Its truths are absolute. It values beauty and elegance above all other things. What matters is the work, the world being explored. Everything else, including authorship and credit, is secondary. That is kind of true. Lots of math transcends who it comes from, because facts, it's all logical, it's all facts, it all makes sense, right? But it can get messy, right? So like, you guys have probably watched Oppenheimer. And Oppenheimer is such a good movie. Christopher Nolan did a great job on that. I actually happened to study nuclear stuff at the time, so all the context made some sense to me. And I just rewatched it recently. People have egos, man. And man, is it like the research behind it all? You just realize that people are just people. And I happen to fit in that category, that I'm like very cocky and stuff. So yes, it is all funny that like people are super egotistical and have their flaws and stuff like that. But like their stuff, what they study is actually like all right or good. But the whole journey, they could be like a home wrecker or like a cheater, or like they can, they have like skeletons in their closet, but they are still recognized because they did something very important, which is one research field into one thing, and that develops a lot of things. So that's kind of neat. Let's see. But this masks the reality of how the pursuit of scientific truth works. Math is a collective enterprise. Ferrier said, even in the case of set theory, you don't have this wonderful example of a single guy inventing the whole thing. Make sense? It also masks the truth that math is done by people. It's impossible to divorce egos and opinions from personal flaws of the work itself. Wonderful. Goose likes to reply. Wonderful. Goose likes to reply to those mathematicians who dismiss Cantor's misconduct. The next paper you write, make it anonymous. Then we'll see if it's about the science. When it comes to their own work, mathematicians are very concerned with credit. Of course. That's why if we die, we hope that somebody like 500 years from now does something with your thing. It's different from like physics or engineering or other sorts of research where it's almost immediate that you can use the stuff right now. But math is like, okay, I have the goal to like make something cool. I need to make a new theorem. I need something to make sense, and it needs to last the test of time because it's in fact true. And it's called the me theorem because I'm special and I want my name on it. That's what people want. So, standing the test of time. Many of them have a near encyclopedic knowledge of who came up with which theorem and who won which awards. Because credit's important. The revelation about Cantor's result doesn't undermine his legacy. He's still the first person to prove that there are more real numbers than whole ones, which is what ultimately opened up the infinity to study. It's really the second theorem that's important in my view. Hamkin said, and the original proof that theorem wasn't Dedekind's. So still wasn't his. But it's still important to recognize Dedekind's role in one of math's greatest discoveries, and Cantor's discussion not to credit him. Ultimately, Cantor's choices only reduce him from hero to human, in a more honest picture. And Cantor was a man who did not easily connect with other people, Richter said. It was very, very hard for Cantor. He was very young, very passionate, and enthusiastic, Ferrios said. And he made a big mistake. This, in the end, is the better story because it's true. Pretty good article. This is a brilliant breakdown of how this. So I'm gonna look into this guy. The author here, credit to him for putting this well-written story together. So Cancer has his flaws. Dedekind was a chill dude, and he did nothing wrong. I think Dedekind be Dedekind to him. Dedekind means to be Dedekind. Okay? And then Cancer, thank you very much, but you're a flawed man. And it's very funny. So yeah, I guess shout out to Joseph Howlett, the writer for this one. This is a very fascinating story. So I'll probably if you guys want to share this story, I guess I'll post this in the Discord then. So you guys are welcome to join. And if you have any friends that happen to like math, I'd hope they do, because why else would you stick around this long? Join the Discord. I'll probably have a different channel for it, but it'd be really cool that I'll be putting stuff in here. I'll probably put this in the maths chat. So that'd be really cool. And I'll probably do some more stuff in the future like that. So yeah, this is my first time reading an article down. I only debuted a few days ago, about a week ago. So I'm new to the space of streaming and stuff. So I hope you guys enjoyed today. And I was, able to break some of this stuff down pretty well. Rest of this time though, I'm gonna say we're gonna finish. I'm gonna prepare my stream schedule, and I'll show you guys how I do my streaming stuff. Almost everything I do is in 3D, which is in Blender. Thank you so much, Atomic. I appreciate it, because like today, I wanted to wind down from my long day today, because I normally don't work on Sundays, and today just happened to be a long thing. So let us go ahead and wrap it up by writing our the schedule out, and finish it from there. Let me show you how I do my let me hide my screen real quick, because I don't want it to show anything sketchy in case anything pops up. I'm looking for where is it at? Okay, let me show you guys how I make my backgrounds for some of these things. So I'm gonna go to, because I'm a Fractal Vtuber, the idea is that my backgrounds, I'm gonna have to try Fractal Explorer. There's tons of like Fractal Explorer websites on the internet. So one of them that I like, I like exploring the Mandelbrot set. So hold on, and again, I'm gonna show you guys this in just a second. So the way that I like to show this, the way that I find a picture for my background, because let me show you what I did last time for my project. So I did schedule maker. You guys would get a kick about how I made this thing. It's in 3D, because I can't do anything that's not in 3D. Imagine that's on screen. Celebration, my bits aren't working. It's okay. Yeah, so this background right here, it's a part of the Mandelbrot set that I took a picture of. So that's how I managed to get the picture out like this. So like today is Sunday, 3/22. That's how I made it. So it's literally in 3D. If that's ridiculous, then it works. Okay, so don't judge me. So we're gonna, what would I want to do? I'm gonna increment this one, so now I can change the dates on this, and I'm just gonna change the background here. So I no longer want this one. It will no longer be rendered. And we're gonna find a part of the Mandelbrot set to depict. So maybe we can do this together then, because I can ask you guys to explore it, and I'll put it in the background for our schedule today. So which part of the set should I look at? I'm looking, this is, if I can explain the scope of it, this is the real number line. So 0's right here. +1 is like over here or so. And -1 is like around here. So if you guys can describe it like coordinates, and it does in fact give you coordinates for some of these. Yeah, so like right now I'm looking at 0.2 and then 0.20. So where would you guys want to like explore at? What's a section we can look? Because I think I grabbed this last picture from one of these images over here. In fact, it was one specific region. It happened to be called 17738. So 17738 or so. So 0.17738. And that's not right. Okay, I totally forgot. It's part of the image data. Don't worry about it. Basically, we get the pretty picture now. Ooh. So, let's go ahead. I'm gonna try looking down here. So this part of the Mandelbrot set, because what happens, this whole big, like, cardioid shape, this little butt, if you will, I work with some students, and they happen to call this a butt all the time. It's really funny. So, I'm gonna look around this region right here. We're gonna look at the crack of the butt, okay? So, and then I'm gonna put this on probably the background. So once we get closer, we're getting lots of similar images. These fractals are cool. And I'll probably generate like some other stuff like this in the future. So let's say you guys want the tip end. It technically doesn't end. Or you guys want like one of these like bigger cone ends. Because right here I can already see some detail like coming out, but it's pretty far out still. So we'd have to get really, really deep to make it look cool. Like this region looks crazy. Oh, this is actually really cool. The cone ends. So what is this? Back over here. This points. Is that what you wanted to try at? Or back over here with the... Yeah. Because if I look here... So the resolution's turned down a lot because it needs to run. But you notice like this particular shape looks very similar to that butt thing. So, yeah, option 2. So not here. Yeah, let's go back to the spirally bits. They were kind of cool. So, I'm going to go, like, right here. Very scientific speech that we're going to do. This is actually really cool. So, how much do you want to zoom on these guys? And then right here, the resolution. If I crank up to high resolution, then it starts like... It should render faster. I'm sorry, less. And that's based on the number of iterations I have. And the iterations are on the side, you can't see it. So let's zoom out a bit because I can't see anything. But what do we have? This looks like a cool shape. All these ones are cool shapes. Why are they all spiraling? They're spiraling spirals. Have you guys watched 𝖈𝖗𝖊𝖉𝖎𝖙𝖘? Or not watched, excuse me, because that was trash. The have you read 𝖈𝖗𝖊𝖉𝖎𝖙𝖘, the horror manga? Spiral one? Junji Ito? Anybody? Guys, this is it. This is what he was getting at the entire time. These are pretty cool though. Let's see. I do like some of these ones are almost like floating, that like they're in space. These are cool too. Let's zoom out a bit now. And so there's still like pockets of spirals. You haven't read it? It's so good. Like you don't necessarily like need to understand it, but the entire thing just talks about spirals. And this is like the biggest epitome of like spirals of spirals of spirals until it never ends. Right? So this is This is really cool. And it looks like this end ends. Wait, how much more does this one end? That was still just that one section. So this little bit right here, this is so cool. Hold on. Okay, sorry. What do you say? Let's go ahead and explore a bit more of this fractal, and then I'm gonna take this picture, and we're gonna use that as the background for our schedule today. I think this looks really cool. So let's see. I'm gonna explore this end right now. So the black parts means that the fractal, the points are not in the set. I'm sorry, that they are in the set. And then anything that's outside is not in the set. So that's how you end up with these weird like shapes that are boundary conditions. So let's see this tip right here. Let me look at this tippy tip. Okay, let me look at this tippy tip. Okay, let me look at this tippy tip. Okay, let me look at this tippy tip. Guys, I think we're not gonna make it. This is cool. So this particular spot right here, I'm gonna zoom out so we can take a look at it. So it's just a larger spiral of a larger spiral of a larger spiral of a larger spiral until eventually it stops. Wait, when does it stop? Oh, that's so cool. So I'm gonna do a few iterations down, like right here. I wish they were GIFs. Oh, I could totally make a schedule a GIF, can't I? That's cool. Okay. What do you guys think about this one? You want to take a picture of this? Because what I can do is I can save this, export this as an image, and then I can import it. So if I do that, I'll probably want to center it just a bit, and then this will give me a resolution size, which I'll get to do. So I'm gonna save it right now. This looks good. Okay. So I have another region of the set that looks cool, and I can also change the colors on this after the fact. So now back over here, what I'm gonna do is I'm gonna add the picture, which I can do like this. So image, mesh plane, and it happens to be, let's see, I'll find it on my schedule set right here. Okay, so now, wait a sec. There we go. Now all I have to do is just make it look pretty cool. Oh yeah, and I need to make sure it emits properly. There we go. Beautiful. So this looks pretty alright. So let me update a few of these terms, right? So it's not going to be the 16th to the 22nd. It's going to be the 23rd to the... Wait, what day is it? Till Sunday? The 29th. Yeah, there we go. You guys will see my process live. What do you call it? My schedule this week. So Monday, I will be off. So that is 23. Tuesday in it. That's going to be the 24th. Let me update all these. 25. Do you want to try making daytimes? Daytimes would be good for streaming. I happen to have like quite a bit morning times, so it'd be good for me to do stuff then, because most people are like at least attentive and will probably want to do like math in the morning. I know trying it on at nighttime right now is a gamble, but that was the only day I could actually do it to make it fun for myself. So that's today, the math talk. It wasn't at 10 a.m. In fact, it was a completely different time. I should probably specify these are all Pacific Standard Time. So let me... Tuesday, I probably will have a gaming stream. So that's gonna be pretty chill. Wednesday, I'm busy. Thursday, if I'm not busy, I'm hoping to do some coding and math. So I guess I'll specify that, like, I'm not really gaming. I'll do OpenGL block. I'll try to make sure that I can install OpenGL. OpenGL is a graphics software. So unlike like Blender like this that I'm playing around in, it's like more coding based. So I'll probably cover that on Tuesday and try to get it installed properly, because my biggest issue is trying to get it to work in the first place. So it'd be good if we can start doing OpenGL stuff, which means that we could do game stuff, right? Without, I'm doing it the hard way. Otherwise, I don't mind doing like a game dev stream to make a game in like Godot or like Unity or something like that. Because the 3D means I have an immediate like pipeline, and all I have to do is like start coding things to make samples. I'll probably be doing that for math demos, so we can like actually see the numbers like crunch out with a visual or animation, and it's like a game style, so it's a rendering live. So that's my idea for like a larger game style graphics, building things up kind of thing. So you can play around with some variables live in your game just to test out a demo, and then hopefully I want them all to be like a puzzle game, and like you guys have to like use all these things to do something. I'll probably call it like Mathmania or something weird. Something cringe like that. Friday, I do have some time, so I'll probably do some... This will be a chill gaming sesh, like actually gaming. Probably 𝖘𝖈𝖎𝖆 𝖕𝖕𝖆. I have yet to play it because it seems so good. But that's also like a gacha game, so I gotta make sure that I have time for it. So it'll be my first time playing it. It's also brand new. Or new from like a month ago. So I'll probably play this. I'll do this at 10 a.m. sesh. Over here would be... Wait, I know you. I'll one. I know you. You're Z. What? You're in Z's chat. Z friend. You're Z friend. You're Orbi. Hello. Hello. I'm wrapping up tonight pretty soon. I'm just delivering my schedule right now, and the fractal we found right here, we found it together. We used the Mandelbrot set. I like to update I'm going to start updating my fractals to be the backgrounds for my schedule. So this is the breakdown for this week. We're going to do an OpenGL block. Hopefully it works. Then we're going to do some coding and math on Thursday. Play some games. We're going to do an 𝖘𝖈𝖆𝖈𝖆 on the 27th. And then hopefully something else on Saturday night. If there is a fractal sound generator, what does that do? Is that like the space one where it's like you get to point at the stars and it generates cool like pleasant sounds? It should be an itch. Maybe I could do that. Maybe that'd be okay. That'd be a good idea. Oh, I wish I could say that. Fractal generator. Maybe. That'd be fun. Fractals plus gaming. If you're welcome to put that in the Discord. I have a Discord. I want to try to get this thing going. Of course, you know, it's just gonna be a hub where we like post stuff and like get things going on projects and communicate stuff. So please do share that in the math chat, please, because that'd be really cool, because then I can cover that and say, hey, we just missed out, you missed out on me talking about an article today. I found out plagiarism is very popular with mathematicians, and oh, that works too if you want to. Yeah, you could whisper that. So I found out today that my namesake, infinities and stuff, they were plagiarized. And you invented the word plagiarism, really? So everything comes back to you. So you're the one that started it. I can't believe this. So all my professors were plagiarizing the word because you plagiarized. That you plagiarized. I'm sorry, that you came up with the word plagiarism. Maybe I'll do that. Maybe I'll do a fractals and gaming sesh. Specifically, I'll do more Arknights. Arknights. Because I need to time sync this. And this will be the quick 10 a.m. I lied. It's gonna be the night sesh, like today, or late. Probably around 8 p.m. PST. Okay. And then last one, I will not be busy. I will be wanting to be busy. Actually, you know, I have another pun for this. I'm gonna call this null because it's funny. Math. Null. All right. And with that, I think that's basically our schedule. I just gotta specify time. This will be 10 a.m. Can't seem to whisper. I know. Try send it to me. Yeah, you can send it in the chat. That's fine. But if you can't, then I know how to get in touch with you. So don't worry too much. Oh, it's a Code Parade thing. Code Parade did this, didn't he? Really? I love Code Parade. He has all sorts of cool like fractal things, and that's one of the reasons why I got super into it. It's because of him. And you know, he does OpenGL too, so that's why, you know, some of that stuff is pretty cool. Okay, issue here with this one. I'm gonna have to lower the. What's the issue here? Texture space. No. It's the line spacing. There you go. Yeah, issues with PC right now. So on mobile, just play safe and homework it, and don't want after and all. Yeah, no worries. We're gonna wrap things up today right now, actually. So it's basically this. So we've did the bulk of our things. We went through an article. I went through the math theorem of the day, which was today's theorem happened to be. I can go back to it real quick. Today's math theorem of the day was the change of variables theorem, which if you've ever done any sort of like Jacobian or changing from spherical coordinates to Cartesian or whatever the case is, that is the theorem where it tells you that it's possible. You're behind in school. If you want, maybe I should probably open up a stream where we like cover questions that you guys can give me, and I can help you guys them through. That'd be good, because clearly I want to help out and I want to do some math stuff, and you guys giving me questions will actually help out a lot. Hold on, we can definitely change this out. So back here, yeah, that'd be tying in with the math block then. So coding and math. So like if you guys have like math stuff, come by on Thursday, and I'll probably try to make more time to do homework stuff. So maybe I'll specify math. What's the cardinality? Yes, so that's the joke. It's not updated properly right now, but that's going to be followers. So cardinality tells you how big the set is. And the whole bit with me being a Fractal VTuber means that you guys are the cardinals. You guys are the how much I have, which is a really cheeky tie-in, right? And because you guys are elements in my set, it's pretty funny. So that's what it means. The cardinality just tells you how big the set is, which tells you how many people there are. Yeah, there's not 100. Actually, my current goal right now is 67 because it's the funny number. Of course. The next number I'll probably do is probably the 2 numbers after that because it's funny as well. Thank you for following. You didn't have to. Well, yes, gets us closer. So thank you so much. Is it as 3 Creftusi? Yes. That means my fractal is restricted. The idea is we're going to keep going until we are, we're going for infinities, right? We'll see how big our cardinal is going to be. That's the point. So what math am I doing? So I'm actually wrapping up my night tonight. We were doing an article about the discussion of infinity. Infinity was plagiarized, and Cantor, he stole infinity from his friend Dedekind. Dedekind, we find out he's pretty chill. I like it. I like Dedekind. Dedekind is a Dedekind guy. You're a string theorist. So maybe kind of, let's see, what do you have to do? Set theory? String theory? Yeah, Dedekind did the funny. He oh, interesting. So string theorist, that's a lot more theory. I was thinking about going to physics, theoretical physics, but I need to be sold on like what's the catch? Adds as anti-Desider. CFT is conformal symmetry. Sussy? Sus! He's the imposter. Is the supersymmetry. That's very cool. That's actually a really cool name. Well, thank you for coming in. I wish I had more stuff to talk about today. We are... Let's see. Maybe I can have you... We have a group chat. We have a Discord. So... If you have a favorite number or a favorite thing to talk about, we are welcome to hear that. We also have a Discord where I'm trying to post regular things. I'm ranking my schedule right now. This isn't Blender, by the way. This is in 3D. So that's my skill set. I happen to have 3D skills, and the idea is that I'll be making animations for the math that we will be discussing. And if not that, then I'd be doing A1. That's gotta be like some sort of joke. You guys take a look at this one thing I did for Z recently. You probably saw it. But I'll show you like the behind the scenes of it because it was pretty funny. It was the black hole sun bit. Favorite number is your social security number. If your social security number was how much money you have, how much money would you have? So dumb. Yeah, it's the black hole sun video. So, let me show you like the behind the scenes, what happened for this project. I made it like in 5 hours because I really wanted to make the thing funny. Very soon, I did not know that she was making a black hole like research video, a stream like the next day because she had just announced it. So I was like, oh crap. So I crunched this out pretty quickly. It was pretty fast. Okay, anytime now. You can. It's got performance issues. It's okay, guys. I thought it was pretty good too. I was like, I did some animation stuff before, on my own time, like as for doing stuff, like how I got good at it. So I would crank out videos daily because that's the same thing to do if you're doing 3D modeling. So I got good at figuring out some of the shortcuts. So that's how today was able, this one was able to be worked out. This one's not responding. I'm going to reload the page. I'm going to close it and start it back again. But if you guys wanted to see the video, I guess I can play it real quick. Let me media player. So let me see. I'm gonna do Z, and I don't want it to be loud either, so for copyright infringement. So basically, yeah, she was doing a stream for Black Hole Suns, and of course, to do that, I had to actually use the Black Hole Sun sound music from Soundgarden. So I wanted to get that out quick, and it was pretty cool. So it was this right here.
Black hole sun, won't you come?
I'm so sorry. I'm so sorry. I'm so sorry, guys. I just completely judged. I'm sorry. Let's how do I do that again? So sorry. Let's see. Okay, so this animation was done in like 5 hours, and you know what? It was pretty good. So that black hole, legitimately, it's a ball, but it does have lensing effects, and it was. I figured since you'd be going into the black hole, like I was gonna do like the black hole gets bigger and the aspect ratio gets big, and then instead I made it like, you know, warp around it, because that's, I think, functionally what light travel does, right? So I thought it was pretty good. And again, the only issue is with the Z's rig. With most Vroid model rigs, they're not Blender like good. Blender likes to do certain things with their naming conventions and suffixes. So what ended up happening is I have limited animation for what it can do. So until I entirely re-rig her bones, then I can make more complicated animations, because then I can make both arms move at once, and the symmetries will work out better. So if you were talking about symmetries and stuff, if you didn't have the right names to each other, then it would not work. So that's the issue here. So let me go back. Blender is not choosing to run. That's funny, because like I think I said this earlier in the stream. I used to love space, but one particular thing ruined it for me, and it was just people not like respecting me trying to appreciate them doing it. If that makes sense. So people were just very egotistical and would say like mean things about it. You know, I knew this one person who had like 17 different like research papers under her name, but she was like credited as like, you know, the simulator. She was like the one doing stuff. So I was like, that's good. You're in the field, you get stuff, right? And she was like, you know, because trying to get publications, trying to get any papers with your name on it is hard. So I was like, what? Just that's amazing. And she was like, yeah, it's whatever. And I was like, what? No, that's a good thing. Like, it's cool. And then she was like, yeah, I guess. I was actually kind of annoyed, because I think she was just trying to rage bait me. But it was like no respect for like actually doing the thing. Okay, hopefully it doesn't crash this time. So let's take a look at the thing real quick, and then I'm gonna wrap this up soon. So you're a real physicist with an actual HEP and scholar profile. See, that's what I'm saying. Like that's cool. That's professional, right? And I respect you for that. That's amazing. You should feel good when people acknowledge that you do that. Maybe not many citations, but it's okay, right? Because at least you have something. I don't have anything yet. I don't have any particular skills just yet, and like, well, I'm broad enough, right? So it's fine. Tell me a joke. I see the jokes you're trying to say. Want a soft math pickup line? Sure. Tell me the best way to pick up the ladies. I want to know how to pick up the ladies. When I'm too rational, you're there to add me the real. You complete me. Oh no, it's so cheesy. I like it. Okay, hold on. When I'm too rational, you're there to add me. You're there to add the real. You complete me. Oh, oh, it's so cheesy. It just might work. I have one. It's not a pickup line, but they're jokes, right? I said this for my debut day, so it's just funny. What do you call a baby 𝖈𝖗𝖆𝖈𝖎𝖆𝖙𝖘? What do you call a baby 𝖈𝖗𝖆𝖆𝖈𝖚? An 𝖈�𝖗𝖆𝖆? What does that mean? A lamb. Duh. Anyways, look at my black hole. Yeah, it's a lamb. Duh. Get it? Get it? A lambda. A lamb. Okay. I love that one. That one's so bad. It's good. I have another one. This is like a group joke. Abstract algebra. If you study that. What do you call it? How do I set this up again? This is a joke I made. So, a mathematician sees a group of girls walking by. The mathematician then makes a comment and says, "Ah, that's a pretty fine group of girls." Get it? It's a pretty affine group of girls. Affine? Affine groups? Get it? Okay. It's a particular type of group, and I forgot what exactly affine means, but affine. It's like AFFINE. Yeah. That one is mid. I know that for sure. Okay. This one's more relevant because of the black hole here. And again, take a look at this. So this had like the rings around it, and really, if you just look at it, it's just a ball with a disc on it, right? So it's got this lensing effect right here, and that's from the shader. And the shader has, it's a really simple one too. Like it has this exponential effect on it, which means that it does warp kind of good. So the joke with the black hole, here's how it goes. Why did the black hole not want to pay for child support? We're going like that. We're going like that. Why did the black hole not want to pay for child support? What? Because it said it wasn't its Schwarzschild. There you go. Yes, you got it. Oh, that's not my Schwarzschild. Yeah, that one was also bad too, but I thought it was funny. It's more dumb. What if you removed the disk and added a light source behind it? So if I did that, so this is parented. So if I just go behind it, please don't break. And then let's say rotate this like 90 degrees. So if we look down here, oopsies, we get this like ringing effect. And just for the sake of like looking at it better, I'm gonna say that this is completely dark. So it's okay. Yeah, this is like now we get to think about dumb stuff now. This is great. So thank you guys for hanging out, because you're not frame dragging accretion. It's not enough for these rings. Okay, well, to be fair, this is faking the black hole, right? So as for the actual like nuances, I am not a space scientist. I am a mathematician. So if I want the picture to look pretty, then it will do it for me. But as for the rigor, as much as I would want to do this rigorously, I don't have a good GPU to even simulate that. I have like Temu style GP graphics card here. I'm running on a budget. So, but actually it'd be really cool to run a simulation of a black hole. And hopefully if it works properly, then I can also use it for animations in here. So like real things like this. So, but the idea for this one was that it had like a lensing effect to it. And that's really all it needs to do, right? So, pretty alright. Pretty alright. It looks like, yeah, well, it needs to be a little black hole. My only issue is that the background here, you notice that it's got some reflection on it. It shouldn't. And that's only because I wanted to have the scape, and I could not get rid of the reflections. It was weird. So unless I just completely like blacken everything else out, then the frame will, well, actually that would have been cooler, wouldn't it? Do tell this joke. I'll probably yeet Z at the moon because she did the Kerbal Space thing the other day. So I'll probably like send her to the moon myself because it's funny. Did you know the B and 𝖈𝖗𝖊𝖉𝖎𝖙𝖘 stands for 𝖈𝖗𝖊𝖉𝖎𝖙? Okay. I walked into that. I did. No way. That is pretty dumb. I like it. I'm gonna save that. Let's see. So maybe I could talk about the C here. The C really quickly. So it's just a simple ocean generator. And I just tweaked the numbers so that it starts out kind of like slow. And then, so like take a look at this time function right here. That tells you how much it's actually like able to transform. And then over here, the scale is another important one. And of course, it needs to get bigger as the black hole gets bigger, right? Write that down. I should make an entire channel that just is math jokes. That's actually probably what I should do. Oh, that'd be good. So okay, by the end here, the thing looks like this. No worries. If it dies, please charge it. If it doesn't die, then fix it. But otherwise, it's been, thank you Atomic for hanging out with us. If it dies, let us know. Let us know when it dies. It's okay. I'm gonna wonder what time it is for you. For Z, let's talk about Z real quick. So this is Z. The way that I got her animation, her mouth, it is a combination of like so many different 1% PST. 1 a.m. Yeah. Oh, let me tell you something cool. And then hopefully it doesn't die. It's 1 a.m. Let me see. So hopefully you are okay. You are PST, but your phone's at 1%, which means here it's 11 o'clock, and then I'd have to. Yeah, I'm not a geometer actually. What is my expertise? I liked combinatorics, discrete mathematics, and a bit of abstract algebra, and hopefully to tie into representation theory. So I guess kind of some stuff with you, but more abstract stuff. So logics, proofs, and stuff like that, that's kind of like my realm, and I enjoyed that a lot. Not necessarily computation or applied stuff. So I'm more of a pure maths kind of guy. So, which is actually kind of hard to say because lots of people are actually like focused on other fields. So they focus on like, oh, I did engineering, I did things like that. I only have bachelor's in math and only just barely. You know what? Getting a bachelor's in math is actually surprisingly, I agree, it's not the craziest. But I have more than one degree, which means that I kind of like learning that stuff. So I did coding, and then I did physics, and then I did math. So more theory based. I really enjoyed that. Okay, maybe I should really open this up for like thinking about graduate level or bachelor's level stuff. I've roasted. I didn't roast. So sorry. I'm sorry. Hopefully the degrees are worth something, because the whole point of me being a anime VTuber in the first place is because I can't find a freaking job. And I believe everybody's with that struggle. Hopefully you'll get a degree. Don't drop out, but if you drop out, make a business that's worth millions. That's usually what people do, right? If you probably do deserve it. Ads, I think so. I think you're a little smart guy. String theory? Heck, if I knew anything about that. You don't have to do quantum stuff? No, that's all quantum stuff, isn't it? No. Or does it get to the realm of abstract where, again, representation theory kicks in and you have to, like, do all of the crazy, like, symmetries and stuff? I don't know. Man, y'all in college? I graduated a long while ago, so hobbying math is hard. Yes, subhumans of the world. Yep. Yeah. It happens. Anyways, let me quickly talk about yeah, business people. Geometry representation theory. And I specifically worked in Langlands. In Langlands? That is a place, right? A Langlands program. It's a set of conjectures about connections between number theory, theory of automorphic forms, and geometry. Ooh. Fascinating. I think I've heard of this before. So, philosophy of cusps forms, formulated a few years earlier than the Harishchandra and 𝖘𝖊𝖉𝖎𝖙𝖘. That's the background. What am I doing? Connections between number theory. It's proposed by Canadians Robert Langlands. It seeks to relate the structure of Galois groups in algebraic number theory and automorphic forms, and more generally, the representation theory of algebraic groups over local fields and ideals. That's interesting. Words, big words. This is fascinating. I wish I could learn more about this one. Oh yeah, you got auto. I'm sorry. Allow. I'm sorry. I should have checked that. I'll check my bot later. Don't worry about it. The moderation stuff. Okay, real quick. I do want to eat. It is late for me, but like dinner hasn't started for me. So I will wrap it up kind of soon. Nah, that's not that bad. I don't think that's bad. I think that's a $2 comment, right? That's like, I've said worse. Okay. Statisticians need to be a statistic. That's what I say. That's crazy. That's crazy to say, but I'm like, I just clearly don't respect the field. That's what I mean. So, you know, I appreciate edgy humor. You guys are chill. You guys are welcome to do that. Twitch, yeah, it was Twitch doing it. So, you're allowed to talk. Okay, let me go ahead and wrap this up tonight. Let me explain some stuff that happened here. So, Z's model here. Let me move this over just a bit so we can see it better. Everything that's green here, the way to make her like work, maybe I shall. Yeah, you're welcome to. I'll just ping it again. But I'm gonna wrap it up again, so I'll probably be in the chat soon. Everything that's green here is a keyframe. So, if I slide some stuff around, you can see that there's different things happening. So if I undo that real quick, then you can see that I've combined them all together to be a mouth that works. So which one is this one? Mouth closed. Neutral. Bruh, no way. So I'm able to switch her her mouth movement, her eye movements, and all sorts of different things by combining these sliders together. So these are called shape keys. So and Vroid Studio has a bunch of default ones. So if I like tone them all down, then that means she should eventually like close her mouth, because by default it's a closed mouth. Otherwise this looks so cringy. Okay, yeah, there we go. All these ones back here. So I combine them all together. And we have some different expressions we can use. So all I did was keyframe these guys. And make it so that the faces that she makes are at least like convincing enough to be expressive, right? Because you can get a lot of expression with just combining stuff. This program, it's Blender. Blender is free. Blender is the art program that you can get for it's 3D modeling, and basically you can get it anywhere. Microsoft stores, Steam, whatever the case is. It's free. Did I mention it's free? So during the pandemic, I took this upon myself because I took a computer graphics class, and all the math made sense because, I mean, think about it. You have the words normals here. You have the word gimbals. You have local coordinates, local things. Lots of things. You can scale things up by their individual origins, by one different axis point, right? So if I change this right here, I can make her rotate around this thing if I wanted to. So if I click her again, then I can like make her rotate around it, even though her body's not connected properly. So that specific one, I can orbit around this thing. Or if I move it over here, then I can orbit around that thing. So you combine all these together to make things work. And again, the math just makes sense to me. I'm not the best at modeling, but I know enough of it. So anyways, I did all that. Her hair, I modeled it. I animated to keep my frame. I don't have an actual like physics sim on it, which would have saved me so much time. And I did have the motion blur. So the motion blur makes it look a little more cooler. So like stuff like, you know, not to like be weird. And it's not. But like her like skirt and stuff. Because she happens to have a skirt. I needed to animate that. Can I like go to the thing, please? They updated or something. Yeah, Blender updates all the time. It's on its 4th version right now. In it brings in this cool thing called geometry nodes, and at some point I'll do geometry nodes, because all the normal math stuff you can think of literally can be done here. So if you have a shape, like, okay, let me actually do something really quickly too, but I'm gonna again wrap up pretty soon. So in geometry, you're probably familiar with this thing called a dual, right? So if I want to make the dual of a mesh, then all I have to do is take the shape, and all the points, all the centers of the faces become a point. So in the middle here, I'm gonna find a point, and that is where a new point would be. And if it's adjacent to another face and another face and another face, then you can do the dual of a cube. But geometry nodes lets me do the thing by myself, and it just does it all for me. So all those points I just showed you, there should be a point here, a point here, point here, and they should all connect. So the dual of a cube looks like a what? And this is like a geometry or like graph theory thing that people do all the time. So the dual of a cube is like this octahedron, right? So what happens if I take the dual of a dual? This is something cool I can do again. If I take the dual of a dual, then all the faces, all the things that I have, right here is going to be a point. Right here is going to be a point. Here's and here, and so on. And then they have to connect again. Turns out you're just remaking the thing. So the dual, you can repeat this many times and it's the same thing, right? Because although technically it does get smaller, I suppose, because you're making a version of it that's smaller. So stuff like that is kind of cool. Geometry nodes is cool because you get to do stuff like that. You get to isolate points and everything, but I have no idea how to use it just yet. One day I'll learn. So yeah, that's really all I have to say about this project here. I had hand animated her hair, her bangs. I had to make sure that they were moving too, to make sure there's movements. Her eyes, the you know, anything that you would be expressive with. Her body, it moves, right? Because of course you want motion too. Anything that has a bone, you want every frame to look like it's moving, which means that it's a more convincing animation. So people that like do animation work, or more amateurs, you'll notice that like when they're static or moving, even subtle movement's good. But here, you know, she doesn't get to move too much because her rig is hard to use. So I get to make sure everything is at least moving so that it gives it more like flavor. And it looks like I did more, which I did, but it's different. Do I know how big Z is? I mean popularity or like size, like height wise? I could probably scale it off her model right now. But yeah, no, I'm familiar with Z. She gave me her model to begin with, so that's how I'm able to do this. How big she is? Tall wise? Oh my god. She's Aleph null size. You got me. I should that makes you mod. That's how it works, right? If you get the streamer, then you become powerful over them. That's how it works. I'm just kidding. I don't think I've just started, so I don't think we're ready for anything like that. But yeah, any questions about this particular project? The terrain was made kind of scuffed. So the mesh that I made is kind of funny. The terrain in the back here is also kind of scuffed because it doesn't really have that much like detail, but it works for like the few frames that exists in. The ocean is a procedural texture, so it comes from combining several different shaders together. So I have a noise texture that looks like this. And using some math to manipulate the values that get out of this, then I get to create a Voronoi texture. And then here, I basically just multiply my numbers together. And it looks convincing enough. It looks busy. So all the values that I have here, they're between zeros and ones. Zeros are blacks and ones are bright, whites. You know? So you can map those values between 0 and 1 as certain colors. So that's how you're able to create things like this. So if I wanted something at 0.5 to be red, so let me go ahead and let's say all the values at 0.5, I want them to be specifically red for whatever reason. Sure. They're done on the front end. I guess they do it once. It's bad sometimes for computation, but it's depending if you have a lot of shaders. So yes, it's kind of bulk work. But as long as it can calculate and there are no errors with the calculations, like dividing by zeros and stuff like that, that it does have fail-safes for. But I mean like big numbers, like overflow errors and stuff, then it would not like that. So yeah, let's say I wanted specifically values of 0.5 and above to be red. Then I can do that. I can isolate that, and I have my ranges. So that's how I'm able to map these colors out. This looks even more scary than before, actually. Maybe I should have done this. So black hole sun, won't you come wash away the rain? Black hole sun, won't you come? I did some simulation research before, like plasma sim stuff. So the stuff that I learned from there, I learned how to like try to not have a bad backend, because optimizations are hard. So you need to make sure that things can run, and you need to know the limits of your system. So in my case, my system happens to be my GPU, which is fine. I have enough RAM, you know, before the AI boom took over. So I'm chilling for now, but I would like to upgrade it at some point. But yeah, that's what I can say about this project right now. I basically did everything in Blender. So yeah, it's pretty chill. Pretty cool. I think this is gonna be about it right now. I just gotta make sure I make my graphic. So let's go back to the other project, my schedule. It's not too hard. I think I will make a tutorial series because it's not the craziest thing in the world. Code and math. At this point, I just admire from afar. That's fine. The other day I covered a theorem and I was doing it all inside of a Blender. Because, of course, as we find RAM test 9 times. Ran RAM test 9 times and all clear. That's good. That means you don't have any leaking memory issues or whatever. Yeah, just take care of your system. If you happen to know what everything does, then it works out just fine. So yeah, this looks like it's going to be the schedule this next week. So OpenGL, I'm going to do that on Tuesday. Thursday, I'll open up to math and coding. So you guys are welcome to come by and give me some stuff to do. And then Friday and Saturday is going to be Arc Nights because I really want to try that game. So with that, I think we're chilling. Let me go ahead and render this and send it out to the void. And the background is a cool picture as well. So if you guys want to see how it looks just like this. This will be in the chat and I'm sorry, in the Discord. I'll ping it one more time. On the broadside, I know the stick itself it's unlikely faulty. It probably isn't. It's just probably just like contacts, or it just needs to be cleaned or whatever the case is. There's all sorts of programs running on your thing, so there's a chance that anything is an issue. So yeah, I'll go ahead and wrap it up here. I'll ping the Discord one more time, and let's go ahead and try to raid somebody. So let's find out who we can bother. We'll look for bleh. Let's see who we can raid. I highly doubt there's anybody up at night doing anything important. So we'll look for a genre. Or actually, okay, there's a Thai streamer. Chit Chat and Sleep. Let's see. There's a Japanese player playing Pokopia. Oh, we can bother Soy. Soy Milk is an engineer. She's an engineer VTuber. She's pretty cool. She doesn't know of me, but I've been there in her chat. She's pretty cool. She recently did a 3D debut. So she's been around for a minute, and I like her projects. So she does smart stuff too. So let's go ahead and check her out. You guys have a fantastic night. What could we say? Actually, what's something funny we can say? 𝖈𝖚𝖆𝖕𝖎𝖙 math is cool. No, something good. Something about infinity. Count your blessings. I don't know. Count on Aleph or something like that. Aleph count on you. Null this set or something like that. I can't think of anything funny. Converge of the series. It's gotta be a math pun. What could we do? Something funny. I will say, nah, you have a good night. I don't know how to say your name, so it's gonna be 𝖈𝖚𝖆𝖕𝖎𝖚𝖙𝑘. The question is, what's a fun raid thing that we can say? To raid soy milk. Something with Aleph in it. Something Aleph or infinities or math. I'll have to figure this out. I'll get this down. A null black holes by Aleph null. That's a good one. Okay, I'll accept that. Null black holes by Aleph null. Sure. Because I did do my thing. Black holes. So, yeah, let's go ahead and roll with that. Okay. You guys good with that? It'll be in the chat, so let's go. Hola milk, soy, alephmuvt. That'd be funny, but I don't think she knows Spanish, so it might not work out. But that's good though. Hold on, that's funny. That's actually good. Oh crap. We'll stick with the no black holes, and we'll get another one going next time. That'd be good. All right. So you guys have a fantastic night. Let's go ahead and raid soy, and have a good night, guys. Bye bye. Bye bye. Have a good night and goodbye. I'll do my outro right now. So there you go. See ya. See ya.